Question 1. A sulfide of iron contains 46.5% of iron by weight. Find the empirical formula of the sulfide. Percentage by weight of iron is 46.5%. So if the weight of the sulfide is 100 grams, then weight of iron present in it is 46.5 grams. Therefore, weight of sulfur will be equal to 100 minus weight of iron, that is 46.5 gram, and this is equal to 53.5 gram. So weight of iron is 46.5 gram, weight of sulfur is 53.5 gram. Moles of iron will be equal to weight of iron divided by atomic weight of iron, that is 46.5 divided by 56, and this is equal to 0.83. Similarly, moles of sulfur will be equal to weight of sulfur divided by atomic weight of sulfur, that is 53.5 divided by 32, and this is equal to 1.67. Now we know the moles of iron and moles of sulfur. Next step is to find the relative number of moles of iron and sulfur, or the ratio of number of moles of iron and number of moles of sulfur. That is number of moles of iron divided by number of moles of sulfur, and this is equal to 0.83 divided by 1.67. Simplifying this is equal to 1 by 2. So number of moles of iron is 1 and number of moles of sulfur is 2. Therefore, empirical formula of the compound will be FeS2. Question 2. 1.60 gram of an oxide of iron on heating in a stream of hydrogen gas completely converted to 1.12 gram of iron. Find the empirical formula of the oxide. Weight of oxide of iron is 1.60 gram. Weight of iron is 1.12 gram. Therefore, weight of oxygen will be equal to weight of the oxide, that is 1.60 gram, minus weight of iron, that is 1.12 gram, and this is equal to 0.48 gram. Now we know the weight of iron and weight of oxygen. Therefore, moles of iron will be equal to weight of iron divided by atomic weight of iron, that is 1.12 gram divided by 56, and this is equal to 0.02 moles. Similarly, moles of oxygen will be equal to weight of oxygen divided by atomic weight of oxygen, that is 0.48 gram divided by 16, and this is equal to 0.03 moles. Now, the ratio of number of moles of iron and number of moles of oxygen, that is moles of iron divided by moles of oxygen, is equal to 0.02 divided by 0.03, and this is equal to 2 by 3. Therefore, moles of iron is 2, moles of oxygen is 3, and the empirical formula of the compound will be, or the empirical formula of the oxide of iron will be Fe2O3. Question 3. Carbon combines with hydrogen to form three compounds A, B, and C. The percentages of hydrogen in A, B, and C are 25%, 14.3%, and 7.7% respectively. Find the empirical formula of the compound. The percentages of hydrogen in A, B and C are given. So if the weight of the compound is 100 grams, then weight of carbon in the compound will be 100 minus the weight of hydrogen. Weight of carbon in B is equal to 100 minus 14.3, which is equal to 85.7 gram, and weight of carbon in C is equal to 100 minus 7.7, which is equal to 92.3 grams. Now moles of carbon in A will be equal to weight divided by atomic weight of carbon, that is 75 divided by 12, and this is equal to 6.25 moles. And moles of hydrogen in A will be equal to weight divided by atomic weight of hydrogen, which is equal to 25 divided by 1, and this is equal to 25. Now the ratio of the moles of carbon and moles of hydrogen will be equal to 6.25 divided by 25, which is equal to 1 by 4. So moles of carbon is 1, moles of hydrogen is 4, and the empirical formula of A will be CH4. Similarly, in B, moles of carbon will be equal to 85.7 divided by 12, which is equal to 7.14, and moles of hydrogen in B will be equal to 14.3 divided by 1, which is equal to 14.3. The ratio of moles of carbon and moles of hydrogen will be equal to 7.14 divided by 14.3, and this is equal to 1 by 2. Therefore, empirical formula of B will be CH2. In compound C, moles of carbon will be equal to 92.3 divided by 12, which is equal to 7.69, and moles of hydrogen will be equal to 7.7 divided by 1, which is equal to 7.7. The ratio of moles of carbon and moles of hydrogen is equal to 7.69 divided by 7.7, which is equal to 1 by 1. So moles of carbon is 1 and moles of hydrogen is 1. Therefore, empirical formula of the compound C will be equal to CH. Question 4. A compound of carbon, hydrogen and nitrogen contains three elements in the respective weight ratio of 9:1:3. Calculate its empirical formula. If its molecular weight is 108, what is its molecular formula? Now the ratio of weight is 9:1:3. Therefore, weight of carbon is 9 grams, weight of hydrogen is 1 gram, and weight of nitrogen is 3 grams. Therefore, moles of carbon will be equal to weight of carbon divided by atomic weight of carbon, that is 9 divided by 12. Moles of hydrogen will be equal to weight of hydrogen divided by atomic weight of hydrogen, that is 1 by 1. And moles of nitrogen will be equal to weight of nitrogen divided by atomic weight of nitrogen, that is 3 divided by 14. Now taking the ratio of the moles of carbon, moles of hydrogen and moles of nitrogen, the ratio of moles of carbon is to moles of hydrogen is to moles of nitrogen will be equal to 9 by 12 is to 1 by 1 is to 3 by 14. And this is equal to, on simplifying this, the ratio will be 3:4:1. Therefore, moles of carbon is 3, moles of hydrogen is 4, and moles of nitrogen is 1. And the empirical formula of the compound will be C3H4N. This is the empirical formula of the compound, and the empirical formula weight will be equal to 3 into atomic weight of carbon, that is 12, plus 4 into atomic weight of hydrogen, that is 1, plus 1 into atomic weight of nitrogen, that is 14, and this is equal to 54. This is the empirical formula weight. Now the ratio of molecular formula weight and empirical formula weight will be, the molecular weight is given as 108 and the empirical formula weight is 54. So 108 divided by 54 will be equal to 2. Therefore the molecular formula of the compound will be C3H4N, and this will get multiplied by 2, and this is equal to C6H8N2. So the molecular formula of the compound will be C6H8N2. Question 5. Question 5. A hydrated salt of iron sulfate weighing 2 gram contains 0.9065 gram of water of crystallization. Find the formula of the hydrated salt. Weight of the hydrated salt is 2 gram. Weight of water of crystallization is 0.9065 gram. Therefore, weight of FeSO4 will be equal to, that is the salt without the water of crystallization, will be equal to 2 minus 0.9065, and this is equal to 1.0935 gram. Let the formula of the hydrated salt be FeSO4 X H2O, where X represents the number of moles of water of crystallization. Now the ratio of the moles of FeSO4 and H2O will be moles of FeSO4 divided by moles of H2O will be equal to 1 by X, as can be seen from the molecular formula. Therefore, X into moles of FeSO4 will be equal to 1 into moles of H2O. So X into what will be the moles of FeSO4? Weight divided by molecular weight of FeSO4, that is 1.0935 divided by 152, and this is equal to 1 into moles of water will be weight divided by molecular weight of water, that is 0.9065 divided by 18. Solving this, the value of X is equal to 7. Therefore, the molecular formula of the compound will be FeSO4 dot 7H2O. Question 6. An iron compound yielded carbon equal to 64.4%, hydrogen equal to 5.5%, and iron equal to 29.9%. What is the simple formula of the compound? The simple formula of the compound means empirical formula of the compound. So if the weight of the compound is 100 gram, then weight of carbon will be 64.4 gram, weight of hydrogen will be 5.5 gram, and weight of iron will be 29.9 gram. Now the formula for the number of moles is weight divided by atomic weight in case of atoms. Therefore, moles of carbon will be equal to 64.4 divided by 12, and this is equal to 5.36. Moles of hydrogen will be equal to 5.5 divided by 1 and this is equal to 5.5, and moles of iron will be equal to 29.9 divided by 56 and this is equal to 0.534. So this is the number of moles. Now in this, the number of moles of iron is the least. So dividing all this by 0.534, we will get a simple ratio, that is 5.36 divided by 0.534 is to 5.5 divided by 0.534 is to 0.534 divided by 0.534. So we get a simple ratio of carbon, hydrogen and iron, that is 10 is to 10 is to 1. Therefore, ratio of carbon is to hydrogen is to iron is equal to 10 is to 10 is to 1. So number of moles of carbon is 10, number of moles of hydrogen is 10 and number of moles of iron is 1. Therefore, the empirical formula of the compound will be C10H10Fe. Question 7. 1.763 gram of hydrated barium chloride was heated to dryness. The anhydrous salt remained was 1.505 gram. What is the formula of the hydrate? Let the formula of the hydrate be BaCl2 dot X H2O, where X represents the number of moles of water or number of moles of water of crystallization. Now weight of hydrated salt is 1.763 gram and weight of the anhydrous salt is 1.505 gram. So weight of water will be equal to 1.763 minus 1.505 and this is equal to 0.258 gram. So this is the weight of water. Now as can be seen from the molecular formula of the hydrated salt, the ratio of number of moles of BaCl2 and number of moles of water of crystallization is 1 is to X. Therefore, it can be written number of moles of BaCl2 divided by number of moles of H2O is equal to 1 by X, cross multiplying X into number of moles of BaCl2 is equal to number of moles of H2O. Now number of moles of BaCl2 will be equal to weight divided by molecular weight of BaCl2. Therefore X into 1.505 divided by 208.3 is equal to number of moles of water will be weight divided by molecular weight of water, that is 0.258 divided by 18. Solving this, the value of X is equal to 2. Therefore, the molecular formula of the hydrated barium chloride will be BaCl2 dot 2H2O. Question 8. A boron hydrogen compound weighing 0.0553 gram created a pressure of 0.658 atmosphere in a bulb of 40.7 milliliter volume at 100 degrees centigrade. Analysis showed it to be 85.7% boron. What is its molecular formula? Percentage of boron in boron hydrogen compound is 85.7%. Therefore, percentage of hydrogen will be equal to 100 minus 85.7 and this is equal to 14.3%. Now pressure is given as 0.658 atmosphere. volume is given as 40.7 milliliter, and temperature is given as 100 degrees centigrade, and this is also equal to 373 Kelvin. Applying the formula, P1 V1 by T1 is equal to P2 V2 by T2. P1 V1 and T1 are the given pressure, volume and temperature. P2 is the standard pressure, that is 1 atmosphere, and T2 is the standard temperature, that is 273 Kelvin. So P2 is equal to 1 atmosphere, T2 is equal to 273 Kelvin, and V2 we have to find out. So putting the values and solving, the value of V2 is equal to 19.6 milliliter. Now we know that the number of moles is equal to volume divided by molar volume, and number of moles is also equal to weight divided by molecular weight. So we can write number of moles of the boron hydrogen compound is equal to volume divided by molar volume, that is 19.6 divided by 22,400, and this is also equal to weight divided by molecular weight of the boron hydrogen compound, that is 0.0553 divided by molecular weight of the boron hydrogen compound. Now solving this equation, the molecular weight of the boron hydrogen compound will be equal to approximately equal to 63. Now percentage of boron in this compound is 85.7%. Therefore weight of boron will be equal to 85.7% of 63, and this is equal to 54 grams. From this, moles of boron will be equal to weight divided by atomic weight of boron, that is 54 divided by 11, and this is equal to 5. Similarly, percentage of hydrogen is 14.3%. So weight of hydrogen will be equal to 14.3% of 63, and this is equal to 9. From this, moles of hydrogen will be equal to weight of hydrogen divided by atomic weight of hydrogen, that is 9 divided by 1, and this is equal to 9. Therefore, molecular formula of the boron hydrogen compound will be B5H9. Question 9. A mixture of 1 volume of gas and 2 volumes of oxygen on explosion formed 2 volumes of CO2 and 1 volume of N2 under the identical conditions of temperature and pressure. Find the formula of the gas. क्वेश्चन में गिवन है कि 1 वॉल्यूम ऑफ अ गैस रिएक्ट करेगी 2 वॉल्यूम्स ऑफ ऑक्सीजन के साथ और इट विल फॉर्म 2 वॉल्यूम्स ऑफ कार्बन डाइऑक्साइड एंड 1 वॉल्यूम ऑफ नाइट्रोजन. टेम्परेचर और प्रेशर कंडीशंस आइडेंटिकल है. क्योंकि ये गैस ऑन रिएक्शन विद ऑक्सीजन कार्बन डाइऑक्साइड और नाइट्रोजन फॉर्म कर रही है, इसलिए ये जो भी गैस है इट इज मेड अप ऑफ कार्बन एंड नाइट्रोजन. तो इसका मॉलिक्यूलर फॉर्मूला हम लिख सकते हैं CXNY. X रिप्रेजेंट करता है नंबर ऑफ मोल्स ऑफ कार्बन और Y रिप्रेजेंट करता है नंबर ऑफ मोल्स ऑफ नाइट्रोजन. अब जो इक्वेशन हो जाएगी रिएक्शन की वो होगी CXNY प्लस O2 फॉर्मिंग CO2 प्लस N2. तो जो भी कार्बन और नाइट्रोजन प्रेजेंट है इस गैस में वो कन्वर्ट हो जाएगी कार्बन डाइऑक्साइड और नाइट्रोजन में. अब क्योंकि रिएक्टेंट्स और प्रोडक्ट्स सब गैसियस स्टेट में है, सो रिलेटिव वॉल्यूम ऑफ रिएक्टेंट्स एंड प्रोडक्ट्स will be equal to relative number of moles. मतलब कि जो भी वॉल्यूम है, कि अगर वॉल्यूम ऑफ द गैस है 1, तो नंबर ऑफ मोल्स ऑफ द गैस भी होगा 1। सो ये है वॉल्यूम और ये है नंबर ऑफ मोल्स। सो वॉल्यूम अगर 1 तो नंबर ऑफ मोल्स भी 1। वॉल्यूम ऑफ ऑक्सीजन है 2 तो नंबर ऑफ मोल्स ऑफ ऑक्सीजन है 2। वॉल्यूम ऑफ कार्बन डाइऑक्साइड है 2 तो नंबर ऑफ मोल्स ऑफ कार्बन डाइऑक्साइड है 2। और वॉल्यूम ऑफ नाइट्रोजन गिवन है 1 तो नंबर ऑफ मोल्स ऑफ नाइट्रोजन है 1। नाउ नंबर ऑफ मोल्स ऑफ कार्बन इन कार्बन डाइऑक्साइड, number of moles of carbon in carbon dioxide is equal to 1 into moles of carbon dioxide, because 1 mole of carbon dioxide में 1 mole of carbon present है. So this is equal to 1 into, अब moles of carbon dioxide कितना है? It is equal to 2 moles. So 1 into 2, so this is equal to 2. Similarly, number of moles of nitrogen in nitrogen gas is equal to 2 into moles of nitrogen, and this is equal to 2 into, अब moles of nitrogen कितना given है? Moles of nitrogen given है 1 mole, so 2 into 1 is equal to 2. अब number of moles of carbon in the given gas, that is number of moles of carbon in CXNY, is equal to number of moles of carbon in carbon dioxide, which is equal to 2. So number of moles of carbon in CXNY will be 2, and number of moles of nitrogen in CXNY will be equal to number of moles of nitrogen in N2, which is again equal to 2. So number of moles of nitrogen in CXNY will be equal to 2. This is because whatever carbon and nitrogen is present in this gas gets converted to carbon dioxide and nitrogen gas. So value of x हो गई 2, value of y हो गई 2. So formula of the gas will be C2N2. Question 10. 9 volumes of a gaseous mixture consisting of a gaseous organic compound A and just sufficient amount of oxygen required for complete combustion yielded on burning 4 volumes of carbon dioxide, 6 volumes of water vapor and 2 volumes of nitrogen. All the volumes measured at the same temperature and pressure. If the compound has only carbon, hydrogen and nitrogen, first, how many volumes of oxygen are required for complete combustion? Second, what is the molecular formula of the compound A? Now, according to the question, the total volume of the gaseous organic compound A and oxygen is 9. Compound A और oxygen का total volume है 9, and after combustion जो भी product बनता है, जैसे कार्बन डाइऑक्साइड, वाटर वेपर एंड नाइट्रोजन, उनके वॉल्यूम है कार्बन डाइऑक्साइड का 4, वाटर वेपर का 6 और नाइट्रोजन का 2, एंड ऑल दीज गैसेस आर एट द सेम टेम्परेचर एंड प्रेशर. तो हम लिख सकते हैं रिएक्शन A plus O2 forming CO2 plus H2O plus N2. टोटल वॉल्यूम A और ऑक्सीजन का है 9, कार्बन डाइऑक्साइड का वॉल्यूम है 4, H2O का वॉल्यूम है 6, नाइट्रोजन का वॉल्यूम है 2. नाउ ऑल द रिएक्टेंट्स एंड प्रोडक्ट्स, जो भी रिएक्टेंट्स और प्रोडक्ट्स हैं, दे आर एट द सेम टेम्परेचर एंड प्रेशर. नाउ ऑल द रिएक्टेंट्स एंड प्रोडक्ट्स, जो भी रिएक्टेंट्स और प्रोडक्ट्स हैं, दे आर ऑल इन गैसियस स्टेट एंड दे आर ऑल एट द सेम टेम्परेचर एंड प्रेशर. सो देयर रिलेटिव वॉल्यूम्स विल बी इक्वल टू देयर रिलेटिव नंबर ऑफ मोल्स. मतलब A प्लस O2 का टोटल नंबर ऑफ मोल्स होगा 9, कार्बन डाइऑक्साइड का नंबर ऑफ मोल्स होगा 4, H2O का नंबर ऑफ मोल्स होगा 6 और नाइट्रोजन का नंबर ऑफ मोल्स होगा 2. जो भी रिलेटिव वॉल्यूम है, that will be equal to relative number of moles. Now, moles of oxygen in O2 will be equal to 2 into moles of oxygen, because 1 mole of oxygen contains 2 moles of oxygen atoms. Similarly, moles of carbon in CO2 will be equal to 1 into moles of carbon dioxide, which is equal to 1 into 4, and this is equal to 4. Now moles of hydrogen in H2O will be equal to 2 into moles of H2O, because 1 mole of H2O contains 2 moles of hydrogen atoms, and this is equal to 2 into moles of H2O is 6, 2 into 6, and this is equal to 12. And moles of nitrogen in N2 will be equal to 2 into moles of nitrogen, and this is equal to 2 into moles of nitrogen is 2, and this is equal to 4. Now according to principle of atom conservation, जो भी total number of atoms reactant side पे है, same product side पे भी same number of atoms होंगे. So number of atoms of oxygen on the reactant side will be equal to number of atoms of oxygen on the product side. Now total moles of oxygen on the reactant side will be equal to total moles of oxygen on the product side. This is according to the principle of atom conservation. So moles of oxygen on the reactant side will be 2 into moles of oxygen, because 1 mole of oxygen contains 2 moles of oxygen atom. So moles of oxygen atom on the reactant side will be 2 into moles of oxygen, and this is equal to moles of oxygen on the product side will be 2 into moles of carbon dioxide, because 1 mole of carbon dioxide contains 2 moles of oxygen atoms, plus 1 into moles of H2O, because 1 mole of H2O contains 1 mole of oxygen, and this is equal to 2 into moles of carbon dioxide है 4 plus 1 into moles of H2O है 6, and this is equal to 14. Therefore, moles of oxygen will be equal to 14 divided by 2, and this is equal to 7. So moles of oxygen, first part of the question जो है, how many volumes of oxygen are required for complete combustion? So moles of oxygen reactant side पे है 7 moles, or we can also say volume of oxygen is equal to 7 volumes. ये हो गया first part of the question. Now in the second part of the question, what is the molecular formula of the compound A? अब compound A में जो भी कार्बन, हाइड्रोजन और नाइट्रोजन है, that got converted into carbon dioxide, H2O and nitrogen. So moles of carbon in compound A will be equal to moles of carbon in carbon dioxide. So moles of carbon in A is equal to moles of carbon in carbon dioxide, जो कि है equal to 4. This is equal to 4. Now moles of hydrogen in A will be equal to moles of hydrogen in water, और moles of hydrogen in water है 12. So moles of hydrogen in A हो गया 12, and moles of nitrogen in A is equal to moles of nitrogen in nitrogen gas, and moles of nitrogen in nitrogen gas is equal to 4. अब ये जो भी moles of carbon, hydrogen और nitrogen है वो है 2 moles of A में, means 2 moles of A contains carbon equals to 4 moles, hydrogen is equal to 12 moles, and nitrogen is equal to 4 moles. So 1 mole of A will contain carbon equal to 4 by 2, which is equal to 2 moles, hydrogen equals to 12 by 2, and this is equal to 6 moles, and nitrogen equals to 4 by 2, which is equal to 2 moles. So अगर 2 moles में 4 moles carbon है तो 1 mole of A में 4 by 2 moles of carbon होगा. 2 moles of A में अगर 12 moles hydrogen है तो 1 mole of A में 12 by 2, which is equal to 6 moles of hydrogen होगा. And 2 moles of A में अगर 4 moles nitrogen है तो 1 mole of A में 4 by 2, which is equal to 2 moles of nitrogen होगा. Therefore, molecular formula of A will be C2H6N2. This is the answer to the second part of the question. Question 11. A sample of gaseous hydrocarbon occupying 1.12 liters at NTP when completely burnt in air produced 2.2 gram of carbon dioxide and 1.8 gram of H2O. Calculate the weight of the compound and the volume of the oxygen at NTP required for its burning. Find the molecular formula of the compound. So कोई भी gaseous hydrocarbon है जिसका वॉल्यूम गिवन है, weight of carbon dioxide produced, weight of water produced given है, and we have to calculate weight of the compound, volume of oxygen, and molecular formula of the compound. Now let the gaseous hydrocarbon be A, and when it reacts with oxygen, product is CO2 plus H2O. अब क्योंकि ये हाइड्रोकार्बन है, so it is made up of hydrogen and carbon. Volume of A given है 1.12 liters. So divide कर देंगे इसको molar volume से, that is 22.4, and we will get moles of A, which is equal to 1 by 20. Volume of oxygen find out करना है. Weight of carbon dioxide given है 2.2 gram. इसको divide कर देंगे molecular weight of carbon dioxide से, that is 44, and we will get moles of carbon dioxide, that is 1 by 20. And weight of water given है 1.8 grams, तो इसको divide कर देंगे molecular weight of water से, that is 18, and number of moles will be 1 by 10 moles. Now moles of oxygen on the reactant side will be equal to moles of oxygen on the product side, or moles of oxygen on the reactant side will be equal to 2 into moles of oxygen gas, and this is equal to moles of oxygen present in carbon dioxide, which will be equal to 2 into moles of carbon dioxide, and moles of oxygen present in H2O, which will be equal to 1 into moles of H2O. So 2 into moles of oxygen will be equal to 2 into moles of carbon dioxide plus 1 into moles of H2O. Because on the product side, carbon dioxide and water are the products containing oxygen. And this will be equal to 2 into 1 by 20 plus 1 into 1 by 10, and this is equal to 1 by 10 plus 1 by 10, which is equal to 2 by 10. From this, moles of oxygen is equal to 2 by 10 into 1 by 2, 2 gets cancelled, and this is equal to 1 by 10 moles. अब moles of oxygen पता चल गया, और moles of oxygen का एक और formula भी है. Moles of oxygen is equal to volume of oxygen divided by molar volume, that is 22.4 liters. तो यहाँ पे moles of oxygen कितना है 1 by 10. So solving this equation, volume of oxygen is equal to 2.24 liters. Now molecular formula of the compound. This compound is hydrocarbon, so it is made up of carbon and hydrogen only. और जो भी कार्बन और हाइड्रोजन प्रेजेंट है इस कंपाउंड में, that got converted into carbon dioxide and water. So moles of carbon in the given hydrocarbon will be equal to moles of carbon in carbon dioxide, which is equal to 1 into moles of carbon dioxide, and this is equal to 1 into 1 by 20, and moles of hydrogen in the given hydrocarbon is equal to moles of hydrogen in H2O, that is equal to 2 into moles of H2O, and this is equal to 2 into moles of H2O कितना है, moles of H2O है 1 by 10, so this is equal to 1 by 5. So 1 by 20 moles of hydrocarbon, which is A, 1 by 20 moles of the hydrocarbon A contains 1 by 20 moles of carbon and 1 by 5 moles of hydrogen. So 1 mole of A will contain 1 mole of carbon and 4 moles of hydrogen. तो इसका मॉलिक्यूलर फॉर्मूला क्या बन जाएगा, इसका मॉलिक्यूलर फॉर्मूला हो जाएगा CH4. So the given hydrocarbon will have the molecular formula CH4. अब number of moles of the hydrocarbon is 1 by 20, and which is also equal to weight of the hydrocarbon divided by molecular weight of hydrocarbon. अब molecular weight of CH4 कितना होगा, it will be equal to atomic weight of carbon, that is 12, plus 4 into atomic weight of hydrogen, which is 1, so it is equal to 16. So weight divided by molecular weight of the hydrocarbon, that is 16, will give the number of moles. Solving this equation, weight of CH4 will be equal to 0.8 grams. Question 12. 0.21 gram of an organic compound containing carbon, hydrogen, oxygen and nitrogen gave upon combustion 0.462 gram of carbon dioxide and 0.1215 gram of H2O. The ammonia produced on distillation of 0.104 gram of this compound with NaOH required 15 milliliter of N by 20 H2SO4 for neutralization. Find the empirical formula of the compound. तो सबसे पहले मिली इक्विवेलेंस ऑफ अमोनिया which is equal to milli equivalents of H2SO4, that is 1 by 20 into 15, and this is equal to 3 by 4. तो milli equivalents of ammonia is equal to 3 by 4, or equivalents of ammonia which is also equal to moles of ammonia will be equal to 3 by 4000. Now 1 mole of ammonia contains 1 mole of nitrogen. So moles of nitrogen will be equal to moles of ammonia, that is 3 by 4000 moles. अब इतने moles of nitrogen जो present है वो है 0.104 gram of compound में. So 0.104 gram of the compound contains 3 by 4000 moles of nitrogen. तो 0.21 gram of compound में कितना nitrogen होगा? 0.21 gram of the compound will contain 3 by 4000 into 0.21 divided by 0.104, and this is equal to 0.0015 moles of nitrogen. अब 0.21 gram of the compound on combustion gives 0.462 gram of carbon dioxide and 0.1215 gram of H2O. So let the compound be A, which on combustion gives carbon dioxide and H2O. अब carbon dioxide कितना है? 0.462 ग्राम. डिवाइड कर देंगे इसको मॉलिक्यूलर वेट ऑफ कार्बन डाइऑक्साइड से, दैट इज 44, एंड वी विल गेट मोल्स ऑफ कार्बन डाइऑक्साइड. और वाटर कितना है? वाटर है 0.1215 ग्राम. इसको भी डिवाइड कर देंगे मॉलिक्यूलर वेट ऑफ वाटर से, दैट इज 18, तो मिल जाएगा मोल्स ऑफ वाटर. अब 1 मोल ऑफ कार्बन डाइऑक्साइड कंटेन्स 1 मोल ऑफ कार्बन, तो मोल्स ऑफ कार्बन इन A विल बी इक्वल टू मोल्स ऑफ कार्बन डाइऑक्साइड. तो मोल्स ऑफ कार्बन डाइऑक्साइड कितना गिवन है? इट इज गिवन एज 0.462 डिवाइडेड बाय 44 विच इज इक्वल टू 0.0105 मोल्स. और मोल्स ऑफ हाइड्रोजन विल बी इक्वल टू 2 into moles of H2O, because 1 mole of H2O contains 2 moles of hydrogen. तो moles of H2O की वैल्यू गिवन है. Putting the value of moles of H2O, moles of hydrogen will be equal to 0.0135 moles. Moles of oxygen will be equal to weight of oxygen divided by atomic weight of oxygen, that is 16. अब weight of oxygen कैसे निकालेंगे? Weight of oxygen will be equal to weight of the organic compound, that is 0.21 gram, minus weight of carbon plus weight of hydrogen plus weight of nitrogen. Weight of carbon क्या होगा? Weight of carbon होगा moles of carbon into atomic weight of carbon, that is 12, plus weight of hydrogen होगा moles of hydrogen into atomic weight of hydrogen, which is 1, plus weight of nitrogen होगा moles of nitrogen into atomic weight of nitrogen, which is 14. अब moles of carbon पता है, moles of hydrogen पता है, moles of nitrogen पता है. Just putting the values and solving, weight of oxygen will be equal to 0.0495 gram. So putting the value of weight of oxygen, that is 0.0495 gram, moles of oxygen is equal to 0.003 moles. About of moles of carbon, moles of hydrogen, moles of oxygen and moles of nitrogen. Moles of nitrogen की value सबसे कम है. So dividing moles of carbon, hydrogen, oxygen and nitrogen by moles of nitrogen, the ratio of carbon is to hydrogen is to nitrogen is to oxygen is equal to 7 is to 9 is to 1 is to 2. So the empirical formula of the compound will be C7H9NO2. Question 13. An organic compound on qualitative analysis was found to contain carbon, hydrogen, nitrogen and oxygen. 1 gram of it on oxidation with copper oxide and oxygen gave 1.239 gram of carbon dioxide and 0.1269 gram of H2O. 2 gram of the sample was digested with concentrated sulfuric acid and the residue was distilled after the addition of excess solution of sodium hydroxide. The ammonia evolved was absorbed in 50 milliliter of 1N sulfuric acid. The resulting solution was diluted to 500 milliliter in a measuring flask. 25 milliliter of this solution required 21.8 milliliter of 0.05 NaOH for complete neutralization. Calculate the empirical formula of the compound. The given organic compound contains carbon, hydrogen, nitrogen and oxygen. The nitrogen present in the compound is converted to ammonia and is absorbed in 50 ml of 1N sulfuric acid, यानी कि 50 milliequivalents of sulfuric acid. So out of this 50 milliequivalents of sulfuric acid, some of it reacts with ammonia while the rest of it is neutralized with 21.8 milliliter of 0.05 NaOH. So total amount of sulfuric acid which is present will be 50 milliequivalents and the remaining sulfuric acid or the sulfuric acid in excess will be equal to milliequivalents of NaOH. And when we will subtract the milliequivalents of remaining sulfuric acid from milliequivalents of the total sulfuric acid, we will get the milliequivalents of ammonia. Total milliequivalents of H2SO4 will be equal to volume of H2SO4 into normality of H2SO4 or normality into volume, that is 1 into 50, which is equal to 50 milliequivalents. Now H2SO4 in excess or H2SO4 left after the reaction will be equal to milliequivalents of NaOH and this is equal to 0.05 into 21.8 milliequivalents. Now these many milliequivalents of H2SO4 are present in 25 milliliter of the solution. Therefore 25 milliliter of the solution contains 0.05 into 21.8 milliequivalents of H2SO4 in excess. Therefore 500 milliliters of the solution will contain 0.05 into 21.8 divided by 25 into 500 and this is equal to 21.8 milliequivalents of H2SO4. Therefore, milliequivalents of H2SO4 used in the reaction will be equal to 50 minus 21.8, which is equal to 28.2 milliequivalents. Now this is also equal to milliequivalents of ammonia and it is also equal to millimoles of ammonia. Now 1 mole of ammonia contains 1 mole of nitrogen. Now moles of nitrogen in ammonia is equal to moles of ammonia, because 1 mole of ammonia contains 1 mole of nitrogen. So moles of nitrogen is equal to moles of ammonia, which is equal to 28.2 divided by 1000, and this is equal to 0.0282 moles. Millimoles of ammonia is 28.2. Therefore, moles of ammonia or moles of nitrogen in ammonia is 0.0282 moles. Now, this is the moles of nitrogen in 2 gram of the compound. Therefore, moles of nitrogen in 1 gram of the compound will be equal to 0.0282 divided by 2, which is equal to 0.0141 moles. Now, moles of carbon in the compound will be equal to moles of carbon dioxide, because 1 mole of carbon dioxide contains 1 mole of carbon. So, moles of carbon in the compound. So, moles of carbon in the compound will be equal to moles of carbon dioxide, which is equal to weight of carbon dioxide given as 1.239 grams divided by molecular weight of carbon dioxide, that is 44, and this is equal to 0.0281 moles. Similarly, moles of hydrogen is equal to 2 into moles of H2O, because 1 mole of H2O contains 2 moles of hydrogen, and this is equal to 2 into weight of H2O जो कि given है 0.1269 ग्राम, और इसको डिवाइड कर देंगे मॉलिक्यूलर वेट ऑफ H2O से, which is 18. So this is equal to 0.0141 moles. तो moles of hydrogen हो गया 0.0141 moles. अब to find moles of oxygen होगा weight of oxygen divided by atomic weight of oxygen, which is 16. A weight of oxygen will be equal to weight of the given compound, which is given as 1, minus weight of carbon. Weight of carbon है moles of carbon into atomic weight of carbon जो कि है 12, plus which is equal to weight of hydrogen. Weight of hydrogen होगा moles of hydrogen into atomic weight of hydrogen जो कि है 1, plus weight of nitrogen, which is equal to moles of nitrogen into atomic weight of nitrogen, which is 14. So weight of the compound जो कि 1 gram है, उसमें से sum of the weight of carbon, hydrogen और nitrogen minus कर देंगे, and we get the weight of oxygen as 0.4513 gram. तो यहाँ पे weight of oxygen की value put कर देंगे, that is 0.4513 grams, and moles of oxygen will be equal to 0.0282 moles. अब moles of nitrogen, carbon, hydrogen और oxygen में least number of moles present है nitrogen और hydrogen के. So moles of nitrogen, carbon, hydrogen और oxygen को least number of moles से divide कर देंगे, और हमें मिल जाएगा ratio of carbon is to hydrogen is to nitrogen is to oxygen जो कि होगा 2:1:1:2. So the empirical formula of the compound will be C2HNO2. Question 14. 0.2614 gram of an organic compound gave upon combustion 0.2324 gram of carbon dioxide and 0.0950 gram of H2O. 0.1195 gram of this compound gave 0.3470 gram of AgCl. If the vapor density of the substance is 49.5, calculate its molecular formula. Vapor density is given. So, molecular weight of the substance will be equal to 2 into vapor density, that is 2 into 49.5. Now we know that 1 mole of silver chloride contains 1 mole of chlorine. So, moles of chlorine will be equal to moles of silver chloride. So, we can write moles of chlorine in 0.1195 gram of the substance is equal to moles of AgCl. और moles of AgCl कितना होगा? Moles of AgCl होगा weight divided by molecular weight of AgCl, which is equal to 0.3470 divided by 143.5. ये तो हो गया moles of chlorine in 0.1195 gram of the substance. But originally कितना लिया गया है substance? The weight of the organic compound taken originally is 0.2614 gram. Therefore, moles of chlorine in 0.2614 gram of the substance will be equal to 0.3470 divided by 143.5 into 0.2614 divided by 0.1195, and this is equal to 0.005 moles. So this is the moles of chlorine present in 0.2614 gram of the organic compound. Now moles of carbon is equal to moles of carbon dioxide, because 1 mole of carbon dioxide contains 1 mole of carbon. Therefore, moles of carbon in the compound will be equal to moles of carbon dioxide, and this is equal to weight of carbon dioxide divided by molecular weight of carbon dioxide, that is 0.2324 gram divided by 44, and this is equal to 0.005 moles. Now 1 mole of H2O contains 2 moles of hydrogen. Therefore, moles of hydrogen is equal to 2 into moles of H2O, which is equal to 2 into, now moles of H2O will be equal to weight of H2O divided by molecular weight of H2O, that is 0.0950 gram divided by 18, and this is equal to 0.0106 moles. Therefore, the ratio of carbon is to hydrogen is to chlorine will be equal to 0.005 is to 0.0106 is to 0.005. The least number of moles is of carbon and chlorine. Dividing all these moles by 0.005, we get the simple ratio, that is 1 is to 2 is to 1. Therefore, empirical formula of this compound will be equal to CH2Cl, and empirical formula weight will be equal to, weight of carbon is 12, weight of 2 atoms of hydrogen will be equal to 2 into 1, that is 2, plus atomic weight of chlorine is 35.5, and this is equal to 49.5. This is the empirical formula weight. Now the ratio of molecular weight and the empirical formula weight will be, molecular weight is 2 into 49.5 divided by empirical formula weight is 49.5. So this is equal to 2. Therefore, molecular formula of the compound will be CH2Cl whole twice, or this is also equal to C2H4Cl2. Therefore, molecular formula of the compound is C2H4Cl2. Question 15. 0.2 gram of a dibasic anhydrous acid produced upon combustion 0.195 gram of carbon dioxide and 0.04 gram of H2O. 0.5 gram of the salt of this acid when ignited converted to 0.355 gram of pure silver. Find the molecular formula of the dibasic acid. Now salt of the acid converted to pure silver, it means the salt was silver salt of the acid. Now the acid is dibasic acid. Dibasic acid means the one which has two replaceable hydrogens, जिसमें दो replaceable hydrogens होते हैं. So we can write its formula as H2A. तो ये हो गया एसिड का फॉर्मूला हैविंग टू रिप्लेसेबल हाइड्रोजन्स. अब सिल्वर का ऑक्सीडेशन स्टेट है +1, हाइड्रोजन का ऑक्सीडेशन स्टेट है +1. So to replace these two hydrogen atoms, 2 atoms of silver will be required. तो अगर ये एसिड है H2A, डाइबेसिक एसिड with 2 replaceable hydrogen atoms, तो इसका सिल्वर सॉल्ट का फॉर्मूला होगा Ag2A. That is, the silver salt will have 2 atoms of silver. So moles of silver salt. So 1 mole of silver salt will contain 2 moles of silver atoms. So we can write 2 into moles of silver salt. अब moles of silver salt कितना होगा? Weight of the salt, which is given as 0.5 gram, divided by molecular weight of the silver salt. Weight of the silver salt given है 0.5 gram, divided by molecular weight of silver salt, let it be X. And this is equal to moles of silver. So moles of silver कितना होगा? Weight of silver, that is 0.355, divided by atomic weight of silver, that is 108. So 2 into moles of silver salt is equal to moles of silver. Solving this, the molecular weight of the salt, that is X, is equal to 304. This is the molecular weight of the salt. Molecular weight of the salt will be equal to 304. Now, from the molecular weight of the salt, if we subtract the weight of 2 atoms of silver and add the weight of 2 hydrogen atoms, we get the molecular weight of the acid. So molecular weight of the acid will be equal to molecular weight of the salt, that is 304, minus 2 into atomic weight of silver, that is 2 into 108, plus weight of 2 atoms of hydrogen, that is 2 into 1, and this is equal to 90. So molecular weight of the acid is equal to 90. Weight of carbon dioxide is given as 0.195 gram. Moles of carbon is equal to moles of carbon dioxide, because 1 mole of carbon dioxide contains 1 mole of carbon, and this is equal to 0.195 gram divided by 44, and this is equal to 0.004 moles. Moles of hydrogen will be equal to 2 into moles of H2O, which is equal to 2 into, what is the weight of H2O? 0.04 gram. So moles of H2O will be 0.04 divided by 18, and this is equal to 0.004 moles. Now weight of oxygen will be equal to weight of the dibasic anhydrous acid, that is 0.2 gram, minus weight of carbon will be equal to moles of carbon, that is 0.004 moles, into atomic weight of carbon, that is 12, plus weight of hydrogen. Weight of hydrogen will be equal to moles of hydrogen, that is 0.004, into atomic weight of hydrogen, that is 1. Solving this, weight of oxygen is 0.148 gram, Therefore, moles of oxygen will be equal to 0.148 divided by 16, and this is equal to 0.009 moles. Therefore, ratio of carbon is to hydrogen is to oxygen is equal to 0.004 is to 0.004 is to 0.009. Dividing, now the number of moles of carbon and hydrogen is the least. So dividing this by 0.004, we get the simplest ratio, that is 1:1:2. Empirical formula of the acid will be equal to CHO2. तो ये हो गया empirical formula of the acid. और empirical formula weight हो जाएगा कार्बन का 12 plus hydrogen 1 plus 2 into oxygen, that is 16, and this is equal to 45. अब molecular weight of the acid पता है, empirical formula weight of the acid पता है. तो molecular formula weight, that is 90, divided by empirical formula weight, that is 45, is equal to 2. तो molecular formula of the acid will be equal to CHO2 whole twice, and this is equal to C2H2O4. What is this 2? This 2 is the ratio between the molecular formula weight and empirical formula weight. तो ये हो गया molecular formula of the acid, or we can also write it as COOH whole twice. So this is the molecular formula of the acid. Question 16. A monoacid organic base gave the following results on analysis. First, 0.10 gram of the base gave 0.2882 gram of carbon dioxide and 0.0756 gram of H2O. Second, 0.20 gram of the base produced 21.8 milliliter of nitrogen at 15 degrees centigrade and 760 millimeter pressure. Third, 0.40 gram of the platinic chloride left 0.125 gram of platinum. Calculate the molecular formula of the base. Now, first find out the molecular weight of the base. Now it is given that 0.40 gram of the platinic chloride left 0.125 gram of platinum. तो मान लेते हैं कि base है B. It reacts with H2PtCl6, which is the acid, to form the platinic chloride, which has the formula B2H2PtCl6, and this gives platinum. Now weight of platinic chloride is given as 0.40 gram. Weight of platinum is 0.125 gram. Now applying principle of atom conservation for platinum atoms. 1 mole of platinic chloride contains 1 mole of platinum. So moles of platinic chloride is equal to moles of platinum. What will be the moles of platinic chloride? Moles of platinic chloride will be equal to weight of platinic chloride, that is 0.40 gram, divided by molecular weight of platinic chloride, let it be X, and this is equal to moles of platinum, which will be equal to 0.125 divided by atomic weight of platinum, which is 195. सॉल्व करेंगे, सॉल्व करने पर molecular weight of platinic chloride आ जाएगा. So molecular weight of platinic chloride, that is X, will be equal to 624. So this is the molecular weight of B2H2PtCl6, and this is equal to 624. अब अगर हम molecular weight of B2H2PtCl6 में से molecular weight of H2PtCl6 subtract कर दें तो we will get the weight of 2 moles of B, and dividing the weight of 2 moles of B by 2 we get the molecular weight of B. So we can write molecular weight of B will be equal to weight of the platinic chloride, that is 624, minus molecular weight of H2PtCl6, which is 410. So this will give the weight of 2 moles of B. So dividing this by 2 will give the weight of 1 mole of B, or the molecular weight of B. And this is equal to 107. So we know the molecular weight of B, or the base. Now moles of carbon is equal to moles of carbon dioxide, and this will be equal to weight of carbon dioxide given as 0.2882 divided by molecular weight of carbon dioxide, that is 44. So moles of carbon will be equal to 0.2882 divided by 44, and this is equal to 0.0065 moles. Similarly, moles of hydrogen will be equal to 2 into moles of H2O, and this is equal to 2 into 0.0756 divided by 18. 0.0756 is the weight of H2O and 18 is the molecular weight of H2O, and this is equal to 0.0084 moles. Now moles of nitrogen. Now this is the moles of carbon and moles of hydrogen in 0.1 gram of the base. Now this is the moles of carbon and moles of hydrogen in 0.1 gram of the base. Now moles of nitrogen. For moles of nitrogen, first of all we need to find the volume of nitrogen at normal temperature and pressure, or under standard temperature and pressure conditions. For that we will use the formula P1V1 by T1 is equal to P2V2 by T2. Here P1, V1 and T1 represent the standard conditions of pressure, volume and temperature. P2, V2 and T2 represent the given pressure, volume and temperature. So given pressure is 760 millimeter of mercury, volume is 21.8 milliliter, temperature is 15 degrees centigrade or 288 Kelvin. Putting the values of P2, V2 and T2, and value of P1 will be 760 millimeter of mercury, T1 will be 273 Kelvin. The value of V1 is equal to 20.66 milliliter. Now moles of nitrogen gas will be equal to volume of nitrogen, that is 20.66 milliliter, divided by molar volume, that is 22400 milliliter. So this is the moles of nitrogen, and moles of nitrogen atoms will be equal to 2 into moles of nitrogen. So this is equal to 2 into 20.66 divided by 22,400 milliliter, and this is equal to 0.0018 moles. Now this is the moles of nitrogen in 0.2 gram of the base. So moles of nitrogen in 0.2 gram of the base, the moles of nitrogen is 0.0018. Therefore in 0.1 gram of the base, the moles of nitrogen will be equal to 0.0018 divided by 0.2 into 0.1, and this is equal to 0.0009 moles. 0.0009 moles. Now the ratio of carbon is to hydrogen is to nitrogen is equal to 0.0065 is to 0.0084 is to 0.0009, and dividing all this by 0.0009 we get the simplest ratio, that is 7 is to 9 is to 1. So the empirical formula of the base is C7H9N, and the empirical formula weight of the base will be equal to 7 into atomic weight of carbon, that is 12, plus 9 into atomic weight of hydrogen, that is 1, plus 14, and this is equal to 107. Now molecular weight of the base is also 107. अब क्योंकि इंपिरिकल फार्मूला वेट और मॉलिक्यूलर फार्मूला वेट दोनों सेम हैं, तो इंपिरिकल फार्मूला और मॉलिक्यूलर फार्मूला भी सेम होंगे. सो द मॉलिक्यूलर फार्मूला of the base will be equal to C7H9N. मॉलिक्यूलर फार्मूला और इंपिरिकल फार्मूला दोनों सेम होंगे. Both empirical formula and molecular formula will be same. Question 17. An organic compound containing carbon, hydrogen, oxygen and sulfur gave the following data on analysis. A. The combustion of 0.1668 gram of the compound resulted in the formation of 0.4540 gram and 0.0663 gram of carbon dioxide and H2O respectively. B. 0.1254 gram of the compound on heating with HNO3 and barium chloride yielded 0.1292 gram of barium sulfate. Calculate the empirical formula of the organic compound. Now weight of the compound is 0.1668 gram. Carbon dioxide का weight दिया है 0.4540 gram and weight of H2O is given as 0.0663 gram. Now 1 mole of carbon dioxide contains 1 mole of carbon. Therefore, moles of carbon dioxide will be equal to moles of carbon, or we can also say moles of carbon will be equal to moles of carbon dioxide. अब moles of carbon dioxide कैसे निकालेंगे? Weight of carbon dioxide given है, so weight of carbon dioxide divided by molecular weight of carbon dioxide will give number of moles of carbon dioxide. So 0.4540 divided by 44 will give moles of carbon dioxide, which is equal to moles of carbon. So moles of carbon is equal to moles of carbon dioxide, which is equal to 0.4540 divided by 44, and this is equal to 0.0103 moles. And weight of carbon will be equal to moles of carbon multiplied by atomic weight of carbon, that is 12, and this is equal to 0.1236 gram. Similarly, 1 mole of H2O contains 2 moles of hydrogen. So, moles of hydrogen will be equal to 2 into moles of H2O, and this is equal to moles of H2O कितना होगा? Weight of H2O, that is 0.0663 gram divided by molecular weight of H2O, that is 18. So moles of H2O हो गया 0.0663 gram divided by 18, and this is equal to 0.0074 moles, and weight of hydrogen will be equal to moles of hydrogen into atomic weight of hydrogen, that is 1. तो weight of hydrogen भी हो जाएगा 0.0074 gram. Now 1 mole of barium sulfate contains 1 mole of sulfur. So moles of sulfur is equal to moles of barium sulfate. और moles of barium sulfate कितना होगा? Moles of barium sulfate होगा weight of barium sulfate, which is given as 0.1292 gram divided by molecular weight of barium sulfate, that is 233.3. Now this is the moles of barium sulfate in 0.1254 gram of the compound. So moles of barium sulfate in 0.1254 gram of the compound will be equal to 0.1292 divided by 233.3, which is equal to 0.0005 moles. So in 0.1254, so in 0.1254 gram of the compound, moles of sulfur is 0.0005 moles. Therefore, in 0.1668 gram of the compound, the moles of sulfur will be equal to 0.0005 divided by 0.1254 into 0.1668, and this is equal to 0.0007 moles. And weight of sulfur will be equal to 0.0007 into atomic weight of sulfur, that is 32, and this is equal to 0.0224 gram. Now weight of oxygen will be equal to weight of the compound, that is 0.1668, minus the sum of the weights of carbon, hydrogen and sulfur, which is equal to 0.1534 grams, and this is equal to 0.0134 gram. Now moles of oxygen will be equal to weight of oxygen divided by atomic weight of oxygen, that is 16. So 0.0134 gram divided by 16 is equal to 0.0008 moles. Now the ratio of moles of carbon is to moles of hydrogen is to moles of sulfur is to moles of oxygen will be equal to 0.0103 is to 0.0074 is to 0.0007 is to 0.0008. Now the least number of moles is of the moles of sulfur, that is 0.0007. Dividing all these number of moles by 0.0007, we get the simplest ratio, that is 14 is to 10 is to 1 is to 1, and therefore the empirical formula of the compound will be C14H10SO. Question 18. An organic compound containing 92.3% of carbon, 7.7% of hydrogen had the molecular weight 26. When treated with bromine, it gave a product containing 92.5% of bromine, but when treated with HBr, it gave a product containing 85.1% of bromine. What is the structural formula of the organic compound? Percentage of carbon given है 92.3%. Percentage of hydrogen given है 7.7%. तो moles of carbon हो जाएगा 92.3 divided by atomic weight of carbon, that is 12, and this is equal to 7.69 moles. Moles of hydrogen will be equal to 7.7 divided by 1. 1 is the atomic weight of hydrogen, and this is equal to 7.7 moles. तो moles of carbon और moles of hydrogen का ratio हो जाएगा carbon is to hydrogen will be equal to 7.69 is to 7.7, or it can also be written as 1 is to 1. तो empirical formula इस compound का हो जाएगा CH, और so this is the empirical formula. और empirical formula weight हो जाएगा, empirical formula weight will be equal to carbon का 12 plus hydrogen का 1 which is equal to 13. अब molecular formula weight या molecular weight जो कि given है 26 divided by empirical formula weight, that is 13, is equal to 2. n की वैल्यू हो गई 2, तो molecular formula हो जाएगा CH whole twice, or this is also equal to C2H2. So this is the molecular formula of the organic compound. Now this is a hydrocarbon containing 2 carbons and 2 hydrogen. So its structural formula will be CH triple bond CH. अब इसको verify कर सकते हैं because second part of the question में it is given when treated with bromine it gave a product containing 92.5% bromine. So अगर addition reaction होता है तो C2H2 में अगर bromine का addition होता है तो we will get a product C2H2Br4. अब इसमें अगर percentage of bromine निकालें तो C2H2Br4 its molecular weight will be its molecular weight is 346 and there are 4 bromine atoms. Therefore weight of all the 4 bromine atoms taken together is 320. So out of 346, 320 is bromine into 100. Therefore percentage of bromine is 92.5%. So percentage of bromine is equal to 92.5% as given in the question. In the same way, when treated with HBr, that is C2H2, when treated with HBr, again there will be addition of HBr and the product will be C2H4Br2. Now percentage of bromine in C2H4Br2 will be weight of the two bromine atoms, that is 160 divided by molecular weight of C2H4Br2, which is 188 into 100, and this is equal to 85.1%, which is the same as given in the question. Therefore the structural formula of the given organic compound is CH triple bond CH. Question 19. An organic aromatic compound X containing 52.2% of carbon, 3.7% of hydrogen and 44.1% of chlorine on oxidation with alkaline KMnO4 gave a monobasic acid Y, the sodium salt of which on distillation with soda lime gave benzene. What is the structural formula of X and Y? First of all, this is an aromatic compound. Percentage of carbon, hydrogen and chlorine is given. Therefore, moles of carbon will be equal to 52.2 divided by 12 and this is equal to 52.2 divided by 12 is equal to 4.35. Moles of hydrogen will be equal to 3.7 divided by 1 which is equal to 3.7 and moles of chlorine will be equal to 44.1 divided by 35.5 which is equal to 1.24. Now dividing all these values by 1.24 we get the ratio of carbon is to hydrogen is to chlorine which is equal to 3.5 is to 3 is to 1 and the simple whole number ratio will be equal to 7 is to 6 is to 2. Therefore, the formula of the compound will be C7H6Cl2. Now as given in the question that this aromatic compound on oxidation with alkaline KMnO4 gave a monobasic acid Y. Monobasic acid means it has only one replaceable hydrogen. The sodium salt of which on distillation with soda lime gave benzene. अब कौन सा सोडियम सॉल्ट है जो कि सोडा लाइम से डिस्टिलेशन के बाद बेंजीन देगा? It will be sodium benzoate. Sodium benzoate जो है on distillation with soda lime gives benzene. This sodium salt will be sodium benzoate. Now since the sodium salt is sodium benzoate, therefore the acid will be benzoic acid. So this monobasic acid Y will be benzoic acid. So we can C7H6Cl2 forms C6H5COOH. Now this is the acid Y which gives the sodium salt C6H5COONA and this sodium salt on distillation with soda lime gives benzene. Now to identify the compound X. Now in this C7H6Cl2, क्योंकि ये aromatic है, therefore it will have C6H5 group and one carbon, one hydrogen and two chlorines are remaining, which will form the side chain. So the formula of the aromatic compound X will be C6H5CHCl2. So this is the aromatic compound X. Question 20. 1 mole of hydrocarbon A reacts with 1 mole of bromine, giving a dibromo compound C5H10Br2. Substance A on treatment with cold dilute alkaline KMnO4 solution forms a compound C5H12O2. On ozonolysis, A gives equimolar quantities of propanone and ethanol. Deduce the structural formula of A. The product of ozonolysis of A are propanone and ethanol. Now, what is the structure of propanone? The structure of propanone is CH3COCH3, and the structure of ethanol is CH3CHO. Now, in ozonolysis, double bond gets replaced by carbonyl group. So, if we consider the carbonyl groups of propanone and CH3CHO, so this is the carbonyl group of propanone and this is the carbonyl group of ethanol. So, before ozonolysis, these carbon atoms, which are part of carbonyl group now, were joined by double bond. So, the structure will be CH3, C, CH3, double bond, C, H, CH3. So, before ozonolysis, this must have been the structure of the compound. Therefore, this is the structural formula of A. And during ozonolysis, this double bond breaks and gets replaced by carbonyl group, giving propanone and ethanol. And when this 1 mole of A reacts with 1 mole of bromine, there is addition reaction taking place at the double bond, giving the product C5H10Br2. Similarly, during treatment with cold dilute alkaline KMnO4, there is addition of two OH groups across the double bond, giving the product C5H12O2. Question 21. An alkene A on ozonolysis yields acetone and an aldehyde. The aldehyde is easily oxidized to an acid B. When B is treated with bromine in presence of phosphorus, it yields compound C, which on hydrolysis gives hydroxy acid D. The acid can also be obtained from acetone by the reaction with hydrogen cyanide followed by hydrolysis. Identify the compounds A, B, C and D. A is the alkene which on ozonolysis gives acetone, that is CH3COCH3 plus an aldehyde, let it be RCHO. Now this acetone on reaction with hydrogen cyanide and followed by hydrolysis gives hydroxy acid D. So acetone CH3COCH3 on treatment with HCN followed by H2O will give a hydroxy acid, that is CH3CH3OH COOH. This is the hydroxy acid which will be obtained when acetone is made to react with hydrogen cyanide followed by hydrolysis. So this is the structure of D. Now it is said in the question that compound C on hydrolysis gives D and compound C is obtained when B is treated with bromine in the presence of phosphorus. So compound C is a bromine containing compound. So structure of compound C can be written as CH3, C, CH3, Br, COOH. This is compound C, which on hydrolysis, what happens? It gives compound D. Now this bromine gets substituted by the hydroxyl group. So compound C on hydrolysis gives compound D, and the structure of D is given here. So this is the structure of C and this is the structure of D. Now the structure of B. B when treated with bromine in the presence of phosphorus gives C. Therefore structure of B will be CH3, C, CH3, H, COOH. So this is the structure of B. Now as can be seen, this compound B contains alpha hydrogen. COOH is the functional group and the carbon attached to the functional group is the alpha carbon and hydrogen attached to the alpha carbon is the alpha hydrogen. So when this compound B containing alpha hydrogen is made to react with bromine in the presence of phosphorus, this alpha hydrogen gets substituted by bromine forming compound C. So this is the structure of B. Therefore B is the acid which is formed from the oxidation of the aldehyde. Therefore the structure of the aldehyde will be CH3, C, CH3, H, CHO. So this is the structure of the aldehyde. Now from the structure of the aldehyde and the structure of the acetone, we can get the structure of the alkene A. Now the carbon atoms which are part of carbonyl group in acetone and in the aldehyde, before ozonolysis, they were joined by the double bond. So the structure of the alkene A will be CH3, C, CH3, double bond C, H, C, H, CH3, CH3. This is the structure of the alkene A. Question 22. An aromatic hydrocarbon A containing 91.3% of carbon and 8.7% of hydrogen on treatment with chlorine gave three isomeric monochloro compounds B, C and D, each having 28% of chlorine. On oxidation with permanganate, all the three gave a monobasic acid. The acid from B on distillation with soda lime gave benzene, while those from C and D gave monochlorobenzene on the same treatment. Assign formula to A, B, C and D. Now moles of carbon is equal to 91.3 divided by 12, which is equal to 7.6 moles. Moles of hydrogen will be equal to 8.7 divided by 1, which is equal to 8.7. Now ratio of moles of carbon to moles of hydrogen is equal to 7.6 divided by 8.7. Now this can be approximately written as 7 by 8, or we can assume the formula of the compound to be C7H8. In this question, the molecular weight is not given. So we can assume the formula of the compound to be C7H8, which also represents the molar ratio of carbon and hydrogen. Now if we take the simple ratio, that is if we divide both 7.6 and 8.7 by 7.6, then we get the ratio of carbon and hydrogen as 1:1.14. Now the moles of carbon is 7. So if we multiply this entire ratio by 7, then also we get the formula as C7H8. And if we find out the percentage of carbon and hydrogen from this formula, then it is same as given in the question. So this is the formula of the compound. Now this compound is aromatic hydrocarbon, therefore it must be having the phenyl group. So the formula of the compound will be C6H5. Now one carbon and three hydrogens are remaining, so this will form the side chain. So the formula of the compound will be C6H5CH3. So this is the compound A. Now this compound A, on treatment with chlorine, it gives compounds, monochloro compounds B, C and D. And on oxidation with permanganate, all these three form monobasic acid, but the acid from B on distillation with soda lime gives benzene. Therefore, the acid which is obtained from B, is benzoic acid, and this on distillation with soda lime gives benzene. Therefore, the formula of the compound B will be C6H5CH2Cl, where chlorine is present in the side chain. There is no chlorine on the benzene ring, and this side chain gets oxidized, giving benzoic acid, which on distillation with soda lime gives benzene. Now for the compounds C and D, they gave monochlorobenzene on the same treatment. Now monochlorobenzene means chlorine group is present on the benzene ring. Therefore the formula for the compound C will be C6H5CH3 with chlorine at ortho position. This is the structure of C, and the structure of D will be C6H5CH3 with chlorine at para position. So this is the structure of D. So when C and D are oxidized and treated with soda lime, they give monochlorobenzene as product. So this is the formula for A, this is the formula for B, this is the formula for C, and this is the formula for D. Question 23. 0.15 gram of an organic compound A gave 0.33 gram of carbon dioxide and 0.18 gram of H2O. The molecular weight of A is 60. The compound A on dehydration gave hydrocarbon B containing 85.7% of carbon. B on successive treatment with hydriodic acid and silver hydroxide gave a product C isomeric with A. Find the structural formula of A, B and C. First of all, we will find the moles of carbon and moles of hydrogen in the given compound A. So moles of carbon is equal to moles of carbon dioxide, which is equal to 0.33 divided by 44, and this is equal to 0.0075 moles. Moles of hydrogen will be equal to 2 into moles of H2O, that is 0.18 divided by 18, and this is equal to 0.02 moles. Now weight of carbon will be equal to moles of carbon multiplied by atomic weight of carbon, that is 12. So this is equal to 0.0075 into 12, and this is equal to 0.09 gram. Weight of hydrogen will be equal to moles of hydrogen, that is 0.02 moles, multiplied by atomic weight of hydrogen, that is 1, and this is equal to 0.02 grams. Therefore weight of oxygen in the compound is equal to 0.15 minus 0.09 plus 0.02, and this is equal to 0.04 gram. From this moles of oxygen will be equal to 0.04 divided by 16, and this is equal to 0.0025 moles. Now the simplest ratio between carbon, hydrogen and oxygen in this compound will be, we will just divide all these moles by 0.0025. So we get the simplest ratio. 0.0075 divided by 0.0025 will give 3 is to 0.02 divided by 0.0025 will be equal to 8 is to, and 0.0025 divided by 0.0025 will be equal to 1. So the simplest ratio between carbon, hydrogen and oxygen is 3 is to 8 into 1. Therefore, the formula will be C3H8O and the molecular weight calculated from this formula. Now this is the empirical formula, and the empirical formula weight calculated is 60, which is equal to the molecular formula weight. So this is also the molecular formula of the compound. Now this is the formula for A. Since this compound undergoes dehydration, dehydration hota hai is compound ka, that means it contains OH group, and its formula, structural formula will be CH3CH2CH2OH. Now on dehydration, it gives hydrocarbon B. So if this compound undergoes dehydration, if this compound A undergoes dehydration, then the product will be CH3, CH2, CH2OH on dehydration will give CH3, CH double bond CH2. This is the structure of the compound B. Now this B on successive treatment with hydriodic acid and silver hydroxide gives product C, which is isomeric with A. So B will change into a product which is isomeric with A. Means C is also an alcohol, but in case of A is a primary alcohol and B will be a secondary alcohol, that is CH3, CHOH, CH3. This is the structure of C. So A is primary alcohol, C is secondary alcohol, or we can say that C is isomeric with A. Question 24. Compound A with molecular weight 108 contained 88.89% carbon, and 11.11% hydrogen. It gave a white precipitate with ammoniacal silver nitrate. Complete hydrogenation. Atom of A gave another compound B with molecular weight 112. Oxidation of A gave an acid with equivalent weight 128. Decarboxylation of this acid gave cyclohexane. Give structures of A and B. Percentage of carbon given है, percentage of hydrogen given है. Moles of carbon will be equal to 88.89 divided by 12, and this is equal to 7.40. Moles of hydrogen हो जाएगा 11.11 divided by 1, which is equal to 11.11. So परसेंटेज कंपोजिशन, जो भी परसेंटेज ऑफ कार्बन गिवन है उसको एटॉमिक वेट ऑफ कार्बन से डिवाइड कर देंगे तो मोल्स ऑफ कार्बन मिल जाएगा, और परसेंटेज ऑफ हाइड्रोजन को एटॉमिक वेट ऑफ हाइड्रोजन से डिवाइड कर देंगे तो मोल्स ऑफ हाइड्रोजन मिल जाएगा. अब मोल्स ऑफ कार्बन और मोल्स ऑफ हाइड्रोजन को 7.40 से डिवाइड कर देंगे, वी गेट अ सिंपल रेशियो बिटवीन कार्बन एंड हाइड्रोजन which is equal to 1:1.5. अब इस रेशियो को 2 से मल्टीप्लाई कर देंगे, so we get the ratio of carbon and hydrogen as 2:3. तो एम्पिरिकल फॉर्मूला हो जाएगा इस कंपाउंड A का C2H3 और एम्पिरिकल फॉर्मूला वेट हो जाएगा, एम्पिरिकल फॉर्मूला वेट हो जाएगा 12 2 24 प्लस 3 विच इज इक्वल टू 27 और मॉलिक्यूलर वेट गिवन है 108। तो वैल्यू ऑफ n हो जाएगा 108 डिवाइडेड बाई 27 विच इज इक्वल टू 4। तो मॉलिक्यूलर फॉर्मूला ऑफ A हो जाएगा C2H3 होल और इसको मल्टीप्लाई कर देंगे 4 से, C2H3 होल 4 एंड दिस इज इक्वल टू C8H12। तो ये हो गया मॉलिक्यूलर फॉर्मूला ऑफ A। अब ये कंपाउंड जो है, कंपाउंड A, इट अंडरगोज हाइड्रोजनेशन। इसका मतलब दिस कंपाउंड हैज आइदर डबल बॉन्ड और ट्रिपल बॉन्ड। अब लास्ट पार्ट ऑफ क्वेश्चन अगर देखें तो ऑक्सीडेशन ऑफ A गेव एसिड with equivalent weight of 128 and decarboxylation of this acid gave cyclohexane। तो A के ऑक्सीडेशन से एसिड मिला और इस एसिड के डीकार्बोक्सिलेशन से साइक्लोहेक्सेन यानी C6H12 मिला। तो इससे ये कंक्लूजन निकाल सकते हैं कि ये जो A है इट कंटेन्स अ साइक्लोहेक्सिल ग्रुप दैट इज C6H11 ग्रुप। A कंटेन्स साइक्लोहेक्सिल ग्रुप और इसमें एक साइड चेन प्रेजेंट है और साइड चेन में आइदर इट हैज डबल बॉन्ड और ट्रिपल बॉन्ड। नाउ टू नो वेदर इट इज अ डबल बॉन्ड और ट्रिपल बॉन्ड, हाइड्रोजनेशन ऑफ A गिव कंपाउंड B with molecular weight 112। सो A का अगर हम हाइड्रोजनेशन कर दें तो B फॉर्म होता है। तो A का मॉलिक्यूलर वेट है 108 और B का मॉलिक्यूलर वेट है 112। सो मॉलिक्यूलर वेट का जो डिफरेंस है 112 माइनस 108 दिस इज इक्वल टू 4। सो यानी हाइड्रोजनेशन करने पर इट्स मॉलिक्यूलर वेट इंक्रीज्ड बाय 4 and each hydrogen atom has atomic weight of 1. So we can make out that 4 atoms of hydrogen are added to A, or we can also say 2 molecules of hydrogen are added and A changes to B. 2 molecules of hydrogen are added to A during hydrogenation and it changes to B. So A contains a side chain having triple bond. So the formula for A can be written as C6H11 cyclohexyl ring जिसमें कि which contains 6 carbons and 11 hydrogen, and in the side chain there is the 7th carbon and there is a triple bond between the 7th and the 8th carbon, and this is the structure of A. We can also write the formula for A as C6H11 C triple bond CH. Now the formula of B which is formed by hydrogenation of A will be C6H11 CH2 CH3. This is the formula for B, or its structure can also be written as the cyclohexyl ring CH2 CH3. Question 26. 448 milliliter of a hydrocarbon A having carbon 87.80%, hydrogen 12.19%, weigh 1.64 gram at NTP. On hydrogenation, it gives 2-methyl pentane. Treatment of A with acidic HgSO4 gives a new compound B of molecular weight C6H12O. Compound A does not react with ammoniacal silver nitrate. What is the structure of A? Moles of carbon will be equal to percentage of carbon को divide कर देंगे 12 से 87.80 divided by 12 and this is equal to 7.316 moles. Moles of hydrogen will be equal to 12.19 divided by 1 which is equal to 12.19. तो परसेंटेज कंपोजिशन ऑफ कार्बन को डिवाइड कर दिया एटॉमिक वेट ऑफ कार्बन से तो मोल्स ऑफ कार्बन मिल गया. परसेंटेज ऑफ हाइड्रोजन को डिवाइड कर देंगे एटॉमिक वेट ऑफ हाइड्रोजन से तो मोल्स ऑफ हाइड्रोजन मिल जाएगा. अब बोथ मोल्स ऑफ कार्बन और मोल्स ऑफ हाइड्रोजन को 7.316 से डिवाइड करेंगे तो कार्बन इस टू हाइड्रोजन का रेशियो मिल जाएगा 1:1.6. इसको 3 से मल्टीप्लाई कर देंगे तो कार्बन और हाइड्रोजन का रेशियो हो जाएगा 3:5. तो एम्पिरिकल फॉर्मूला ऑफ A is equal to C3H5. C3H5 और एम्पिरिकल फॉर्मूला weight of A is equal to 36 plus 5 which is equal to 41. अब वॉल्यूम ऑफ A गिवन है और वेट ऑफ A गिवन है तो मोल्स ऑफ A will be equal to volume that is 448 divided by molar volume that is 22,400 milliliter or moles of A is also equal to weight of A that is 1.64 gram divided by molecular weight of A. इस इक्वेशन को सॉल्व करेंगे तो molecular weight of A will be equal to 82. अब molecular weight को डिवाइड कर देंगे empirical formula weight से तो वैल्यू ऑफ n हो जाएगा 82 divided by 41 which is equal to 2. तो empirical formula को मल्टीप्लाई कर देंगे 2 से और we can say the molecular formula will be C3H5 whole twice which is equal to C6H10. तो ये हो गया molecular formula of A. ये हो जाएगा molecular formula of A. Now according to this formula, this hydrocarbon contains 6 carbons. So according to the general formula, a 6 carbon alkane has the formula C6H14. But A में number of hydrogen है सिर्फ 10. It means this compound has 4 hydrogen atoms less or it is a unsaturated hydrocarbon. अब क्योंकि 4 hydrogen atoms less हैं तो either it has 2 double bonds or it has 1 triple bond. अब molecular formula तो इस compound का पता चल गया. Molecular formula of A हो गया C6H10 and on hydrogenation it gives 2-methyl pentane. यानी इसका hydrogenation कराएंगे A का तो A के hydrogenation पे हमें मिलेगा 2-methyl pentane. 2-methyl pentane का स्ट्रक्चर हो गया CH3 CH CH3 CH2 CH2 CH3. So this is the structure of 2-methyl pentane which is obtained on hydrogenation of A. Now according to the question, treatment of A with acidic HgSO4 gives a new compound B. इसका मतलब A reacts with acidic HgSO4 to give a new compound B of molecular formula C6H12O. This shows that the compound A has triple bond and it undergoes hydration when treated with acidic HgSO4. Now we need to find out the position of triple bond, whether it is present at the terminal position, that is at the end of the chain, or it is internal. Now on treatment of compound A with ammoniacal silver nitrate, A does not react with ammoniacal silver nitrate. This shows that the triple bond in A is internal because only terminal alkynes react with ammoniacal silver nitrate. So the structure of A will be CH3 CH CH3 C triple bond C CH3. So this will be the position of triple bond. It will not be present at the end of the chain. It will be present between these two carbons. So this is the structure of A. Question 27. 0.369 gram of a bromo derivative of a hydrocarbon A when vaporized occupied 67.2 milliliter at NTP. A on reaction with aqueous NaOH gives B. B when passed over alumina at 250 degrees centigrade gives a neutral compound C, while at 300 degrees centigrade it gives a hydrocarbon D. D when treated with HBr gives an isomer of A. When D is treated with concentrated sulfuric acid and the product is diluted with water and distilled, E is obtained. Identify A to E. So according to this question, there is a hydrocarbon. Let the formula of the hydrocarbon be RH. Now, ये हाइड्रोकार्बन फॉर्म करता है एक ब्रोमो डेरिवेटिव. लेट इट्स फॉर्मूला बी BR which is called A और इसका वेट है 0.369 ग्राम. A को जब वेपोराइज करेंगे इट विल ऑक्यूपाई अ वॉल्यूम 67.2 milliliter. Then again A on reaction with aqueous NaOH gives B. तो B का फॉर्मूला होगा ROH. This is B. It gives B. B when passed over alumina at 250 degrees centigrade. It gives a neutral compound C. B gives a neutral compound C when passed over alumina at 250 degrees centigrade. But B at 300 degrees centigrade gives a hydrocarbon D. D when heated with HBr gives a isomer of A, and D when treated with concentrated sulfuric acid and the product is diluted with water and distilled, E is obtained. Now we have to identify the compounds A, B, C, D and E. So first of all, number of moles is equal to volume divided by molar volume. Volume कितना है? A का वॉल्यूम है 67.2 milliliter divided by molar volume, that is 22,400 milliliter, और number of moles is also equal to weight divided by molecular weight. तो A का weight है 0.369 gram divided by molecular weight of A, let it be X. Solve करेंगे तो value of X will be equal to 123 और molecular weight of A is equal to 123. So A का जो जनरल फॉर्मूला हमने लिया है वो है RBR. अब इसमें ब्रोमीन का वेट है 80. सो एल्काइल चेन का वेट हो जाएगा 123 माइनस 80 विच इज इक्वल टू 43. अब एल्काइल चेन का वेट पता है तो वी कैन फाइंड आउट द स्ट्रक्चर ऑफ द एल्काइल चेन. CH3 ग्रुप का वेट होता है 15, CH3 CH2 का वेट होता है 29 एंड CH3 CH2 CH2 का वेट होता है 43. So the alkyl group which is attached to bromine is CH3 CH2 CH2. तो यहाँ जो ये एल्केन है उसका फॉर्मूला हो जाएगा CH3 CH2 CH3 और A का स्ट्रक्चर हो जाएगा CH3 CH2 CH2 Br. Now A when treated with aqueous NaOH gives alcohol B. So CH3, CH2, CH2, Br when treated with aqueous NaOH, it will give B, and the structure of B will be CH3, CH2, CH2, OH. So this is the structure of B. Now B when passed over alumina at 250 degrees centigrade gives a neutral compound C, while at 300 degrees centigrade it gives a hydrocarbon D. At low temperature, two molecules of B will join together with elimination of water molecule to give a neutral compound C, or we can say intermolecular dehydration will take place. So the structure of C will be CH3, CH2, CH2, O, CH2, CH2, CH3. In this, the two molecules of B have joined together with the elimination of water. The general reaction can be shown as this is one alcohol and this is another alcohol, and there will be elimination of water molecule and they will join together to form a ether. So in this same way, two molecules of B with the elimination of water and formed ether. So this is the structure of C. C is a ether. But when B is heated at high temperature with alumina, then the elimination of water molecule takes place from the same molecule, from the molecule of B, or there is intramolecular dehydration reaction. So the compound formed will be, or the structure of D will be, D is equal to CH3, CH double bond, CH2. So the reaction which must have taken place is, ये है structure B का CH3CH, H, CH2, OH. तो जब high temperature पे heat करेंगे with alumina, that is at 300 degrees centigrade, if it is heated with alumina, there will be elimination of water molecule from the same molecule. तो compound बन जाएगा CH3, CH double bond, CH2, which is the structure of D. D when heated with HBr gives isomer of A. तो D को जब HBr से ट्रीट करेंगे, यानी कि D को जब HBr से ट्रीट करेंगे, that is CH3, CH double bond CH2 when treated with HBr, तो इसमें जो compound बनेगा, it will be isomer of A. So the structure of the compound will be CH3, CH, Br, CH3. Now this is the isomer of A which is formed on treatment of D with HBr. And D when treated with concentrated sulfuric acid and the product is diluted with water and distilled, E is obtained. अब जब D को concentrated sulfuric acid के साथ treat करेंगे and the product is diluted with water, there will be addition of H2O across the double bond and the product E will have the structure CH3, CH, OH, CH3. This is the structure of E. Question 28. When 0.90 gram of an organic compound C4H10O2 A was treated with sodium, 224 milliliter of hydrogen were evolved at NTP. Compound A could be separated into two fractions B and C by crystallization, of which fraction B could be resolved into optical isomers D and E. Write down the structural formula for C, D and E with proper reasoning. Now according to the question, the compound A reacts with sodium and hydrogen is evolved, which means this compound A may contain COOH group or OH group. But the double bond equivalent of this compound A is 0. Double bond equivalent of compound A is 0. Therefore, it does not contain COOH group. It contains OH group. Now A is separated into two fractions B and C by crystallization, and B could be resolved into optical isomers D and E. Therefore, the structure of D and E is as given here, and the structure of C will be this. Question 29. An organic compound A has 76.6% carbon and 6.38% hydrogen. Its vapor density is 47. It gives characteristic color with aqueous FeCl3 solution. A, when heated with CO2 and NaOH at 140 degrees centigrade under pressure, gives B, which on being acidified gives C. C reacts with acetyl chloride to give D, which is a well-known painkiller. Identify A, B, C and D. First of all, the vapor density is given as 47. Therefore, the molecular weight will be equal to 2 into vapor density, which is equal to 94. Now, moles of carbon can be obtained by dividing the percentage of carbon by its atomic weight. So, moles of carbon is 6.38. Similarly, moles of hydrogen is 6.38. अब percentage of oxygen निकाल लेंगे which is equal to 100 minus percentage of carbon plus percentage of hydrogen which is equal to 18.02%. अब moles of oxygen निकालने के लिए percentage of oxygen को divide कर देंगे atomic mass of oxygen से. Moles of oxygen is equal to 1.12. अब ratio of the moles of carbon, hydrogen and oxygen is 6.38 is to 6.38 is to 1.12. अब इन सबको डिवाइड कर देंगे 1.12 से. सो वी गेट अ सिंपल रेशियो दैट इज 6:6:1. तो इसका इंपिरिकल फॉर्मूला जो हो जाएगा ए का वो होगा C6H6O. नाउ इंपिरिकल फॉर्मूला वेट निकाल लेंगे. इंपिरिकल फॉर्मूला वेट इज इक्वल टू 94. सो मॉलिक्यूलर वेट और इंपिरिकल फॉर्मूला वेट दोनों ही इक्वल हैं. देयरफॉर मॉलिक्यूलर फॉर्मूला और इंपिरिकल फॉर्मूला भी सेम होंगे. तो इस कंपाउंड का मॉलिक्यूलर फॉर्मूला भी हो जाएगा C6H6O. नाउ अकॉर्डिंग टू द क्वेश्चन, दिस कंपाउंड गिव्स कैरेक्टरिस्टिक कलर विद FeCl3 solution, which means this compound is either a phenol or a salicylic acid. अब इस कंपाउंड का जो मॉलिक्यूलर फॉर्मूला है that corresponds to the formula of phenol. Therefore, compound A is phenol. And later on, when it is heated with carbon dioxide and NaOH, then it forms sodium salt of salicylic acid. So B is the sodium salt of salicylic acid, which on being acidified changes to salicylic acid or 2-hydroxybenzoic acid, which is C. Now on treatment with acetyl chloride, it leads to the formation of the compound D, which is acetyl salicylic acid, and is also a well-known painkiller known by the name aspirin. Question 30. An unknown compound of carbon, hydrogen and oxygen contains 69.77% carbon and 11.63% hydrogen and has a molecular weight of 86. It does not reduce Fehling solution but forms a bisulfite addition compound and gives a positive iodoform test. What are the possible structures? सबसे पहले moles of carbon और moles of hydrogen निकाल लेंगे, which we can find out by dividing the percentage composition by its atomic weight. So moles of carbon हो गया percentage of carbon divided by its atomic weight, which is equal to 6. Moles of hydrogen हो गया percentage of hydrogen divided by its atomic weight, which is equal to 11.63 divided by 1, and this is equal to 11.63. Percentage of oxygen होगा 100 minus percentage of carbon plus percentage of hydrogen, which is equal to 18.6%. अब percentage of oxygen पता है तो moles of oxygen हो जाएगा percentage of oxygen divided by its atomic weight, that is 18.6 divided by 16, which is equal to 1.16. Now ratio of the moles of carbon, hydrogen and oxygen is 6:11.63:1.16. अब इन सबको डिवाइड कर देंगे 1.16 से. सो सिंपल रेशो मिल जाएगा विच इज इक्वल टू 5:10:1। तो इंपिरिकल फॉर्मूला हो जाएगा गिवन कंपाउंड का C5H10O। अब इंपिरिकल फॉर्मूला वेट हो जाएगा 12 into 5 plus 10 plus 16 which is equal to 86। अब इसका मॉलिक्यूलर वेट भी जो है वो 86 है। So molecular formula will be same as the empirical formula. So molecular formula of the compound will be C5H10O. Now from this molecular formula we can confirm one thing, that this compound does not contain benzene ring, because at least 6 carbon atoms are required for benzene ring. Now this compound does not reduce Fehling solution, which means it may be a ketone, but it forms a bisulfite addition compound. Now bisulfite addition reaction is shown by carbonyl group. Now carbonyl group is present in aldehydes as well as in ketones. So since this compound forms a bisulfite addition compound, if it is a ketone, then most probably it is a methyl ketone. Now this compound also gives a positive iodoform test which confirms that this compound is a methyl ketone. Methyl ketone matlab the compound will have CH3CO group. Now इसके molecular formula में 5 carbons, 10 hydrogens और एक oxygen है. Now the CH3CO group accounts for 2 carbons, 3 hydrogens and 1 oxygen. So अब कितने carbons और hydrogen बच गए? 3 carbon and 7 hydrogens are left, which means this CH3CO group is attached to a C3H7 group. अब ये 3 carbons अगर straight chain में arrange होंगे without any branches, then this is one of the possible structure of the methyl ketone. And if this 3 carbon chain is branched, then this is the another possible structure of the methyl ketone. Question 31. An organic compound X, molecular weight is given as 44, contains 54.54% of carbon and 9.09% of hydrogen. With PCl5, X gives a compound of molecular weight 99. On oxidation, it gives an acid of molecular weight 60. What is X? Now, since on oxidation it gives acid, therefore the given compound is either aldehyde or a alcohol. Percentage composition of carbon and hydrogen is given. Subtracting the sum of the percentages of carbon and hydrogen from 100 will give the percentage of oxygen. अब जो भी percentage composition given है, for example percentage of carbon को divide कर देंगे atomic weight of carbon से, तो moles of carbon मिल जाएगा which is 4.5 moles. Percentage of hydrogen को divide कर देंगे atomic weight of hydrogen से, तो moles of hydrogen मिल जाएगा which is 9.09 moles. Similarly, percentage of oxygen को divide कर देंगे atomic weight of oxygen से, तो moles of oxygen मिल जाएगा which is 2.3 moles. Now the ratio of the moles of carbon, hydrogen and oxygen is equal to 4.5:9.09:2.3. अब इन सब को 2.3 से divide कर देंगे तो we get a simple ratio that is 2:4:1. तो empirical formula X का हो जाएगा C2H4O. अब empirical formula weight हो जाएगा, there are 2 carbons, so 2 into 12 plus 4 as there are 4 hydrogens plus 16 as there is 1 oxygen. So empirical formula weight will be equal to 44. अब empirical formula weight और molecular weight दोनों same है. Therefore the molecular formula is also C2H4O. Now as we assume that the given compound is either aldehyde or an alcohol, तो अब 2 कार्बन aldehyde जो है वो होगा CH3CHO और 2 कार्बन alcohol अगर होगा तो the formula will be CH3CH2OH. Now if we compare the number of hydrogens and carbon, तो इस alcohol में number of carbons है 2 और number of hydrogen है 6, which does not correspond to the given molecular formula of X. But in acetaldehyde, the number of carbons is 2, number of hydrogens is 4 and number of oxygen is 1. So the formula of acetaldehyde corresponds with the given molecular formula of X. So the given compound X is acetaldehyde, it is not alcohol. अब जो given reactions हैं like on oxidation, CH3CHO on oxidation gives CH3COH, and if we find its molecular weight, it is 60. And CH3CHO with PCl5 gives CH3CHCl2 plus POCl3. अब CH3CHCl2 का अगर molecular weight निकालेंगे तो it will be equal to 99. Therefore, the given compound is acetaldehyde. Question 32. A ketone A which undergoes haloform reaction gives compound B on reduction. B on heating with H2SO4 gives compound C which forms monogenide D. D on hydrolysis in the presence of zinc dust gives only acetaldehyde. Identify A, B and C. Question में given है कि A is a ketone. It undergoes haloform reaction. So if it undergoes haloform reaction, then we can say that this is a methyl ketone. Therefore, A will have a CH3CO group. Now, A on reduction gives B. B when treated with H2SO4 or on heating with H2SO4 gives C. अब H2SO4 से जब हीट करेंगे तो B will undergo dehydration to give C. C forms monogenide which on treatment with H2O and zinc forms only one product that is CH3CHO. अब इस सीरीज में हम प्रोडक्ट से रिएक्टेंट की तरफ जाएंगे. We will proceed from product side to the reactant side. तो अगर ओजोनोलिसिस के बाद सिर्फ CH3CHO बन रहा है एज अ प्रोडक्ट, देयरफॉर जो मोनोजेनाइड होगा उसका स्ट्रक्चर कुछ ऐसा होगा. ये जो कार्बोनिल कार्बन है CH3CHO का, this carbonyl carbon is bonded to the oxygens in this monogenide. तो जब इसका हाइड्रोलिसिस होगा मोनोजेनाइड का in the presence of zinc, तो ये बॉन्ड इस तरह से ब्रेक करेगा and we get the only product that is CH3CHO. So this is the structure of monogenide D. Now D is formed from C. Therefore C contains a carbon-carbon double bond. और C में जो double bond है वो इन दोनों कार्बन्स के बीच में प्रेजेंट होगा. तो अगर हम इन दोनों कार्बन्स को डबल बॉन्ड से ज्वाइन कर दें, we get the structure of C. So these are the two carbons which were joined to the oxygen in monogenide, but before the formation of monogenide, these two carbons are joined with a double bond. So this is the structure of C. And C is formed by treatment of B with H2SO4. और H2SO4 से जब हम ट्रीट करते हैं, B undergoes dehydration. So C को अगर B में convert करना है तो we have to add water across this double bond. Or by adding water across the double bond, we get the structure of B. So on adding H2O across this double bond, we get the structure of B and this is the structure of B. Now B is formed by the reduction of A and A contains a CH3CO group. B का अगर oxidation कर देंगे, then we get the structure of A. So B on oxidation will give a methyl ketone and this is the structure of methyl ketone or this is the structure of A. Question 33. An organic compound A having molecular weight 58 contains 62.06% of carbon and 10.35% of hydrogen and rest oxygen. A on reduction gave B, which gave iodoform test. B on dehydration gave an unsaturated hydrocarbon C having molecular weight 42. Find A, B and C. Percentage of carbon given है 62.06%, percentage of hydrogen given है 10.35%, तो percentage of oxygen हो जाएगा 100 minus percentage of carbon plus percentage of hydrogen and this is equal to 27.56%. Now moles of carbon होगा percentage of carbon divided by atomic weight of carbon, तो moles of carbon हो गया 5.17 moles. Moles of hydrogen is equal to percentage of hydrogen divided by atomic weight of hydrogen. So moles of hydrogen is 10.35. Moles of oxygen is equal to percentage of oxygen divided by atomic weight of oxygen. So moles of oxygen is equal to 1.7. Now the ratio of the moles of carbon, hydrogen and oxygen is 5.17 is to 10.35 is to 1.7. Now dividing all these by 1.7, the moles of carbon, hydrogen and oxygen is in the ratio 3 is to 6 is to 1. So the empirical formula will be C3H6O, and empirical formula weight will be, there are 3 carbons and atomic weight of carbon is 12. So 3 into 12 plus there are 6 hydrogens and atomic weight of hydrogen is 1. So 3 into 12 plus 6 plus atomic weight of oxygen, that is 16. So empirical formula weight is 58. Now empirical formula weight and molecular weight are same. Therefore molecular formula will also be C3H6O. So from the molecular formula we know that A is a 3 carbon compound. Now according to the question, B gave iodoform test. We know that iodoform test is given by methyl ketones, and iodoform test is also given by secondary alcohols having CH3CHOH group. These secondary alcohols having CH3CHOH group, they can be oxidized into methyl ketones. Therefore, these secondary alcohols also give iodoform test. Now, B is formed by the reduction of A. So, number of carbon atoms in A and B will be same. 3CHOH group contains 2 carbon atoms. Therefore, if this CH3CHOH group is bonded to a methyl group, then it accounts for the third carbon atom, and the structure of B is CH3CHOH CH3. This is the structure of B. B is formed by the reduction of A. So if we oxidize B, we get A. So on oxidation of B, it forms methyl ketone, that is CH3COCH3. This is acetone. So this is the structure of A. Now B on dehydration gives C. Dehydration करेंगे B का तो H2O remove हो जाएगा and we get a unsaturated compound C. अब C का molecular weight find out करेंगे तो C का molecular weight होगा 42 and A का molecular weight calculate करेंगे तो A का molecular weight होगा 58. So A का molecular weight is same as given in the questions. Molecular weight of C is also same as given in the question. So these are the structures of A, B and C. Question 34. An aromatic compound X contains carbon 79.25% and hydrogen 5.66%. X on treatment with alkali gave a neutral product Y containing carbon 77.78% and hydrogen 7.41%, and the sodium salt of an aromatic organic acid Z, which on distillation with soda lime gave benzene. Assign structural formula to X, Y and Z. सबसे पहले तो X is an aromatic compound, तो इसमें C6H5 ग्रुप प्रेजेंट है. Z is an organic acid, जिसके सोडियम सॉल्ट का सोडा लाइम से डिस्टिलेशन कराने पे वी गेट बेंजीन. इट मीन्स the sodium salt is the sodium salt of benzoic acid and therefore Z is benzoic acid. Now, moles of carbon in X is equal to percentage of carbon divided by atomic weight of carbon, which is equal to 6.6. Moles of hydrogen is percentage of hydrogen divided by atomic weight of hydrogen, which is equal to 5.66. Percentage of oxygen is equal to 100 minus percentage of carbon plus percentage of hydrogen, which is equal to 15.09%, and therefore moles of oxygen is equal to percentage of oxygen divided by atomic weight of oxygen, which is equal to 0.943 moles. अब moles of carbon, moles of hydrogen और moles of oxygen को divide कर देंगे 0.943 से. So we get a simple ratio of the moles of carbon, hydrogen and oxygen, which is equal to 7:6:1. X का molecular formula हो जाएगा C7H6O. Now X is an aromatic compound. X एरोमेटिक कंपाउंड है तो X में C6H5 ग्रुप प्रेजेंट होगा. अब अकॉर्डिंग टू द मॉलिक्यूलर फॉर्मूला देयर आर 7 कार्बन्स, 6 हाइड्रोजन्स एंड 1 ऑक्सीजन. तो C6H5 में 6 कार्बन और 5 हाइड्रोजन आ गए. So 1 carbon, 1 hydrogen and 1 oxygen is left. And 1 carbon, 1 hydrogen and 1 oxygen can make a functional group which is CHO. Therefore X क्या होगा? X हो जाएगा C6H5CHO. Now X on treatment with alkali gave a neutral product Y. अब Y में moles of carbon हो जाएगा percentage of carbon divided by atomic weight of carbon which is equal to 6.48. Moles of hydrogen हो जाएगा percentage of hydrogen divided by atomic weight of hydrogen which is equal to 7.41. Percentage of oxygen होगा 100 minus percentage of carbon plus percentage of hydrogen which is equal to 14.81%. Moles of oxygen हो जाएगा percentage of oxygen divided by atomic weight of oxygen that is 16 and this is equal to 0.921 moles. अब moles of carbon, moles of hydrogen और moles of oxygen को divide कर देंगे 0.921 से and we get a simple ratio of the number of moles of carbon, hydrogen and oxygen in Y which is equal to 7:8:1. तो Y का molecular formula हो जाएगा C7H8O. Now C6H5CHO on treatment with alkali gave a neutral product Y and sodium salt of aromatic acid which on distillation with soda lime gave benzene. Therefore the sodium salt of aromatic acid must be sodium benzoate and the acid will be benzoic acid. So C6H5CHO forms acid. Here it is the sodium salt of the acid and a alcohol. ये जो alcohol है, it is Y. If we compare the molecular formula of this alcohol and molecular formula of Y, then both are the same. Therefore, Y is C6H5CH2OH and Z is C6H5COOH. So C6H5CHO forms C6H5CH2OH and sodium salt of benzoic acid, and this sodium salt of benzoic acid on distillation with soda lime gives benzene. Therefore Z is benzoic acid and Y is C6H5CH2OH. Question 35. An aromatic compound X contained 58.5% of carbon, 4.1% of hydrogen and 11.4% of nitrogen. X may be obtained by the action of HNO3 on a compound Y. X on reduction gives a monoacid organic base Z. Give structural formula of X, Y and Z. First of all, moles of carbon, moles of hydrogen, moles of nitrogen find out कर लेंगे. Moles of carbon होगा percentage of carbon divided by atomic weight of carbon which is equal to 4.875. Moles of hydrogen will be equal to percentage of hydrogen divided by atomic weight of hydrogen and this is equal to 4.1. Moles of nitrogen is equal to percentage of nitrogen divided by atomic weight of nitrogen and this is equal to 0.814 moles. A percentage of oxygen निकाल लेंगे which is equal to 100 minus percentage of carbon plus percentage of hydrogen plus percentage of nitrogen. So percentage of oxygen is equal to 26. अब moles of oxygen होगा percentage of oxygen divided by atomic weight of oxygen which is equal to 1.6 moles. अब इन सबको divide कर देंगे 1.6 से. So simple ratio of the moles of carbon, hydrogen, nitrogen and oxygen मिल जाएगा which is equal to 6:5:1:2. Now according to the question में given है कि the given compound is aromatic compound. Aromatic compound मतलब उसमें C6H5 group present होगा. C6H5 group के लिए we need 6 carbons and 5 hydrogen. तो moles of carbon, hydrogen का जो ratio है वो है 6:5. So 6 carbon और 5 hydrogen हमें यहाँ से मिल जाएंगे. Or we can say that empirical formula and molecular formula is the same. अब इसमें बच गया एक नाइट्रोजन और दो ऑक्सीजन. So 1 nitrogen and 2 oxygen make up the functional group, that is NO2 group. Therefore X is C6H5NO2. अब जो भी reactions given है X के in the question उससे हम verify कर लेंगे. X may be obtained by the action of HNO3 on compound Y. तो compound Y क्या हो सकता है? Compound Y हो सकता है benzene, because benzene when acted upon by HNO3 gives C6H5NO2. So Y is benzene, and next X on reduction gives monoacid organic base Z. So X का अगर हम reduction कराएंगे, C6H5NO2 का अगर हम reduction कराएंगे, it will give C6H5NH2. Therefore structure of Z is, or Z is C6H5NH2. Question 36. An aliphatic amine X contains carbon 61.01%, hydrogen 15.25%, and nitrogen 23.74%. X on treatment with HNO2 gave an alcohol Y having carbon 60% and hydrogen 13.33%. Y on careful oxidation gave Z of vapor density 29. Z gave iodoform test. Assign structural formula to X, Y and Z. Now it is given in the question that X is an aliphatic amine. Moles of carbon in X is 5.084 moles, which is obtained by dividing the percentage of carbon with atomic weight of carbon. Moles of hydrogen is 15.25 moles, which is obtained by dividing the percentage of hydrogen by atomic weight of hydrogen. Moles of nitrogen is 1.696 moles, which is obtained by dividing the percentage of nitrogen with atomic weight of nitrogen. Now dividing all these three by 1.696, we get a simple whole number ratio of the moles of carbon, hydrogen and oxygen, which is 3:9:1. This shows that X is a 3 carbon compound, and since it is amine, it has NH2 group. Now moles of carbon in Y is 5, moles of hydrogen in Y is 13.33, and moles of oxygen in Y is 1.66. For moles of oxygen, we will subtract percentage of carbon plus percentage of hydrogen from 100, and we get percentage of oxygen, that is 26.67%, and dividing the percentage of oxygen by its atomic weight gives the moles of oxygen. Now dividing moles of carbon, moles of hydrogen and moles of oxygen by 1.66, we get a simple ratio between moles of carbon, hydrogen and oxygen, which is equal to 3:8:1. Now this compound Y is also a 3 carbon compound, and Y is a alcohol. Y on oxidation gives Z, which gives iodoform test and whose vapor density is 29. तो vapor density 29 है तो molecular weight हो जाएगा 2 into vapor density, that is 2 into 29, which is equal to 58. अब Z iodoform test देता है and it is formed by the oxidation of alcohol, which means Z is a methyl ketone, and since it is a 3 carbon compound, therefore the structure of Z will be CH3COCH3. So Z is acetone, and Z is formed by oxidation of Y, or on reduction of Z we get Y. So the structure of Y will be CH3CHOH CH3. अब Y में जो OH group है, Y is a secondary alcohol, OH group is attached to secondary carbon. Therefore X, the amine, which on treatment with HNO2 gives this secondary alcohol, must be having a NH2 group on the secondary carbon, and therefore structure of X will be CH3CHNH2CH3. So X is CH3CHNH2CH3, Y is CH3CHOHCH3, and Z is CH3COCH3. Question 37. An organic compound A contains carbon is equal to 32%, hydrogen equals to 6.66% and nitrogen equals to 18.67%. On reduction, it gives a primary amine B, which gives ethyl alcohol with nitrous acid. B gives an offensive odor on warming with CHCl3 and KOH and gives compound C, which on reduction forms ethyl methylamine. Assign the structures of A, B and C. अब ये जो ऑर्गेनिक कंपाउंड ए है, ऑन रिडक्शन इट गिव्स अ प्राइमरी अमीन बी. प्राइमरी अमीन मतलब फंक्शनल ग्रुप हो गया NH2 and this primary amine B on reaction with HNO2 that is nitrous acid gives ethyl alcohol. अब ethyl alcohol का फॉर्मूला होता है C2H5OH यानी कि ethyl alcohol which means it contains 2 carbons, 5 hydrogens and the functional group which is present is OH group. Therefore, we can say that this organic compound A, apart from containing carbon, hydrogen and nitrogen, also contains oxygen. So, percentage of oxygen will be equal to 100 minus percentage of carbon plus percentage of hydrogen plus percentage of nitrogen and this is equal to 42.67%. Now, we will find out the moles of carbon, hydrogen, nitrogen and oxygen. तो moles of carbon होगा percentage of carbon divided by atomic weight of carbon which is equal to 2.66 moles. Moles of hydrogen होगा percentage of hydrogen divided by atomic weight of hydrogen which is equal to 6.66 moles. Moles of nitrogen होगा percentage of nitrogen divided by atomic weight of nitrogen which is equal to 1.33 mole. Moles of oxygen होगा percentage of oxygen divided by atomic weight of oxygen which is equal to 2.66 moles. अब मोल्स ऑफ कार्बन, हाइड्रोजन, नाइट्रोजन और ऑक्सीजन को डिवाइड कर देंगे मोल्स ऑफ नाइट्रोजन से बिकॉज द मोल्स ऑफ नाइट्रोजन इज द लीस्ट. सो वी गेट अ रेशियो between moles of carbon, hydrogen, nitrogen and oxygen which is equal to 2:5:1:2. Now we know that when A is reduced, it gives a primary amine which on treatment with nitrous acid gives ethyl alcohol. अब ये ethyl alcohol 2 carbon compound है which means B is also a 2 carbon amine and since B is formed from A then A is also a 2 carbon compound. तो A में भी 2 carbon present है. Now in this molar ratio of carbon, hydrogen, nitrogen and oxygen, moles of carbon is 2. Therefore the molecular formula of A is same as its empirical formula or we can say it is a 2 carbon compound. Therefore formula for A will be C2H5NO2 which on reduction gives B which is C2H5NH2. C2H5NH2 on treatment with HNO2 gives C2H5OH. Now B on treatment with CHCl3 and KOH gives an offensive odor. Now this reaction is known as carbylamine reaction and B on treatment with CHCl3 and KOH gives a isocyanide. The functional group NC is the isocyanide group. Therefore, C2H5NH2 on treatment with CHCl3 and KOH gives C2H5NC and this reaction is also known as carbylamine reaction. C2H5NC on reduction gives C2H5NHCH3. Now, the structure of C is C2H5NC. Therefore, C is C2H5NC. This is a isocyanide. Question 38. Compound A gives positive Lucas test in 5 minutes. When 6 gram of A is treated with sodium metal, 1120 milliliter of hydrogen is evolved at STP. Assuming A contain 1 atom of oxygen per molecule, write the structural formula of A. Compound A gives positive Lucas test in 5 minutes. Usually Lucas test is used to differentiate between primary, secondary and tertiary alcohols. The secondary alcohols give Lucas test in 5 minutes. Now this given compound A contains only 1 oxygen atom per molecule. So it has 1 OH group and it is a secondary alcohol. Now the general reaction of alcohols with sodium metal is ROH plus Na forming RONA plus half moles of H2. Now moles of hydrogen evolved in this case is moles of hydrogen is equal to volume of hydrogen evolved divided by molar volume of hydrogen. Volume of hydrogen evolved divided by molar volume of hydrogen, which is equal to 1 by 20 moles. So moles of hydrogen evolved is 1 by 20 moles. Now moles of A is equal to weight of A divided by molecular weight of A. Weight of A is given in the question as 6 grams, and we assume the molecular weight of A to be X. So X is the molecular weight of A. Now 1 mole of alcohol gives half moles of hydrogen. Therefore 6 by X moles of A will give 6 by X into half moles of hydrogen. Here ROH represents A. Now we can equate the moles of hydrogen. 6 by X into 1 by 2 moles of hydrogen is equal to 1 by 20. Solving this, the value of X is 60. Therefore, the molecular weight of A is 60. Now the simplest secondary alcohol is CH3CHOH CH3. Now if we find the molecular weight of CH3CHOH CH3, it is equal to 60. Therefore, we can say that the given compound A is a secondary alcohol and its formula is CH3CHOH CH3. Question 39. An organic compound A of molecular weight 140.5 has 68.32% carbon, 6.4% hydrogen and 25.26% chlorine. Hydrolysis of A with dilute acid gives compound B C8H10O. Compound B can be oxidized under mild condition to compound C C8H8O. Compound C forms a phenyl hydrazone D with phenyl hydrazine and gives a positive iodoform test. Give the structures of compounds A to D. फर्स्ट ऑफ ऑल परसेंटेज कंपोजिशन ऑफ एटम को डिवाइड कर देंगे उसके एटॉमिक वेट से, तो हमें मिल जाएगा मोल्स ऑफ एटम. सो मोल्स ऑफ कार्बन is equal to 5.7 moles, moles of hydrogen is equal to 6.4 moles, moles of chlorine is equal to 0.71 moles. Now in this the moles of chlorine is the least, so we will divide moles of carbon, moles of hydrogen and moles of chlorine by 0.71 and we will get a simple ratio between moles of carbon, hydrogen and chlorine, which is equal to 8:9:1. So empirical formula of A will be C8H9Cl. Now as given in the question, A का हाइड्रोलिसिस कराएंगे, it will give B. B का मॉलिक्यूलर फॉर्मूला है C8H10O. B का ऑक्सीडेशन कराएंगे तो it will form C, जिसका मॉलिक्यूलर फॉर्मूला है C8H8O. Now in this compound C, it contains 8 carbon atoms. Compound B also contains 8 carbon atoms. और A के empirical formula में भी there are 8 carbon atoms. So we can assume that the empirical formula of A and molecular formula of A both are same and the molecular formula of A is also C8H9Cl. इस formula से अगर हम molecular weight of A निकालेंगे, we will get the same as given in the question, that is 140.5. Now compound C, it gives iodoform test. So we can assume that compound C may be containing either CH3CHOH group or CH3CO group. Now since compound C also gives phenyl hydrazone with phenyl hydrazine, therefore we can assume that compound C contains CH3CO group. अब CH3CO ग्रुप में 2 कार्बन 3 हाइड्रोजन और 1 ऑक्सीजन है and the molecular formula of C is C8H8O. So 6 carbon and 5 hydrogens are remaining. Therefore we can say that CH3CO group is bonded to a C6H5 group. Therefore the structure of C is C6H5COCH3. Now C is formed by the oxidation of B. Therefore, the structure of B will be C6H5CHOHCH3 and B when oxidized will form C. Now A is formed by the hydrolysis. Now B is formed by the hydrolysis of A, and A contains chlorine. Therefore, in A, the carbon that is bonded to OH group in B is bonded to chlorine in A. Therefore, the formula for A will be C6H5. Therefore, the formula for A will be C6H5CHClCH3. And the structure of D will be C6H5 C double bond N NH C6H5CH3. This is the structure of D. Question 40. 10 gram of a mixture of hexane and ethanol are reacted with sodium to give 200 milliliter of hydrogen at 27 degrees centigrade and 760 millimeter mercury pressure. What is the percentage of ethanol in the mixture? Percentage of ethanol in the mixture निकालने के लिए सबसे पहले हमें पता होना चाहिए weight of ethanol in the mixture. Total weight of hexane and ethanol is given as 10 gram. अब जब इस मिक्सचर को सोडियम के साथ रिएक्ट कराएंगे, ओनली इथेनॉल विल रिएक्ट विद सोडियम और ये होगी इसकी इक्वेशन C2H5OH प्लस Na फॉर्म्स C2H5ONa प्लस H2. ये है बैलेंस्ड इक्वेशन. अब ये जो हाइड्रोजन इवॉल्व हुआ उसकी वॉल्यूम है 200 मिलीलीटर एट 27 डिग्री सेंटीग्रेड एंड 760 मिलीमीटर ऑफ मर्करी प्रेशर. नेक्स्ट हम वॉल्यूम ऑफ हाइड्रोजन एट स्टैंडर्ड टेम्परेचर एंड प्रेशर कंडीशंस निकालेंगे. उसके लिए हम फॉर्मूला यूज करेंगे P1V1/T1 इज इक्वल टू P2V2/T2. P1 और T1 स्टैंडर्ड प्रेशर और टेम्परेचर है विच इज प्रेशर है 760 मिलीमीटर ऑफ मर्करी, प्रेशर है 760 मिलीमीटर ऑफ मर्करी, टेम्परेचर है 273 केल्विन और वॉल्यूम वी हैव टू फाइंड आउट. और P2V2/T2 है गिवन प्रेशर टेम्परेचर एंड वॉल्यूम. प्रेशर गिवन है 760 मिलीमीटर ऑफ मर्करी, टेम्परेचर गिवन है 300 केल्विन और वॉल्यूम ऑफ हाइड्रोजन है 200 मिलीलीटर. इक्वेशन को सॉल्व करने के बाद जो वॉल्यूम ऑफ हाइड्रोजन आएगा वो है 182 मिलीलीटर. अब वॉल्यूम ऑफ हाइड्रोजन अंडर स्टैंडर्ड प्रेशर एंड टेम्परेचर कंडीशंस वी नो, तो यहाँ से हमें मिल जाएगा मोल्स ऑफ हाइड्रोजन which is equal to volume of hydrogen divided by molar volume. Moles of hydrogen is equal to 91 divided by 11,200. अब अगर हम ये balanced equation को देखेंगे, we can see that 2 moles of C2H5OH gives 1 mole of hydrogen. So we can write 1 mole of hydrogen is given by 2 moles of C2H5OH. Therefore, 91 divided by 11,200 moles of hydrogen will be given by 2 into 91 by 11,200 moles of C2H5OH. अब moles of C2H5OH पता है, molecular weight of C2H5OH होता है 46. तो moles of C2H5OH को multiply कर देंगे molecular weight of C2H5OH से, we will get the weight of C2H5OH in the mixture which is equal to 0.7475 gram. Now we can find out the percentage of C2H5OH which is equal to weight of C2H5OH in the mixture. This will be 0.7475 gram divided by total weight of the mixture which is given as 10 gram into 100. Therefore, percentage of C2H5OH is equal to 7.475%. Question 41. A mixture of 0.535 gram of ethanol and acetaldehyde when heated with Fehling's solution gave 1.2 gram of a red precipitate. What is the percentage of acetaldehyde in the mixture? इथेनॉल और एसिटाल्डिहाइड के मिक्सचर में से एसिटाल्डिहाइड रिएक्ट करेगा विथ फेहलिंग सोल्यूशन और इक्वेशन जो है रिएक्शन की वो ये है CH3CHO प्लस CuO फ्रॉम फेहलिंग सोल्यूशन फॉर्म करेगा CH3COOH प्लस Cu2O. अब हम एज्यूम कर लेंगे वेट ऑफ एसिटाल्डिहाइड इक्वल्स टू x ग्राम्स। इक्वेशन बैलेंस्ड है और फ्रॉम बैलेंस्ड इक्वेशन वी कैन सी मोल्स ऑफ एसिटाल्डिहाइड एंड मोल्स ऑफ Cu2O इज सेम। अब मोल्स ऑफ एसिटाल्डिहाइड का फॉर्मूला क्या होगा? वेट ऑफ एसिटाल्डिहाइड डिवाइडेड बाय मॉलिक्यूलर वेट ऑफ एसिटाल्डिहाइड। तो ये हो गया x डिवाइडेड बाय 44। 44 क्या है? 44 है मॉलिक्यूलर वेट ऑफ एसिटाल्डिहाइड। अब वेट ऑफ Cu2O क्या गिवन है? वेट ऑफ Cu2O गिवन है 1.2 ग्राम। तो मोल्स ऑफ Cu2O कितना हो जाएगा? मोल्स ऑफ Cu2O हो जाएगा वेट ऑफ Cu2O दैट इज 1.2 ग्राम डिवाइडेड बाय मॉलिक्यूलर वेट ऑफ Cu2O दैट इज 143। So moles of CH3CHO is equal to moles of Cu2O। इस इक्वेशन को सॉल्व करेंगे तो हमें x की वैल्यू मिल जाएगी विच इज इक्वल टू 0.369 ग्राम। तो वेट ऑफ CH3CHO जो प्रेजेंट है मिक्सचर में वो है 0.369 ग्राम। अब परसेंटेज ऑफ CH3CHO विल बी इक्वल टू वेट ऑफ CH3CHO divided by total weight of the mixture into 100 and this is equal to 68.9%. Question 42. An organic compound A containing carbon, hydrogen, nitrogen and oxygen on analysis gives 49.32% carbon, 9.59% hydrogen and 19.18% nitrogen. A on boiling with NaOH gives off ammonia and a salt which on acidification gives a monobasic nitrogen free acid B. The silver salt of B contains 59.67% silver. Deduce the structures of A and B. A percentage of carbon, hydrogen और nitrogen given है। कंपाउंड में ऑक्सीजन भी प्रेजेंट है तो हम परसेंटेज ऑफ ऑक्सीजन निकाल लेंगे विच इज इक्वल टू 100 माइनस sum of the percentage of carbon, hydrogen and nitrogen and this is equal to 21.91%. This is the percentage of oxygen. A percentage composition of atom divided by its atomic weight will give the moles of atom. So ये फॉर्मूला लगा के हमें moles of carbon, hydrogen, nitrogen और oxygen मिल जाएगा which is equal to moles of carbon हो गया 4.1 moles, moles of hydrogen हो गया 9.59 moles, moles of nitrogen हो गया 1.37 मोल and moles of oxygen हो गया 1.37 moles. अब इन सब moles में 1.37 is the least value तो इन सबको डिवाइड कर देंगे 1.37 से। We get the simple ratio of the moles of carbon, hydrogen, nitrogen and oxygen which is equal to 3:7:1:1। अब ये जो रिएक्शन है that boiling of A with NaOH gives off ammonia and a salt तो यूजुअली क्या होता है कि यूजुअली जो एमाइड्स होते हैं दैट इज RCONH2 ये हो गया इनका जनरल फॉर्मूला और CONH2 हो गया एमाइड ग्रुप। व्हेन दे आर बॉइल्ड विद NaOH they will give the sodium salt of the acid that is RCOONA plus ammonia. So we can assume that ये जो कंपाउंड A है इसमें जो फंक्शनल ग्रुप प्रेजेंट है वो है अमाइड ग्रुप दैट इज CONH2 ग्रुप। अब ये जो अमाइड ग्रुप है CONH2 इसमें कितने कार्बन्स हैं? कार्बन है एक, नाइट्रोजन है एक, 2 हाइड्रोजन है और एक ऑक्सीजन है। तो ये जो फॉर्मूला है कंपाउंड ए का जो एम्पिरिकल फॉर्मूला होगा वो होगा C3H7NO। लेट अस अज्यूम कि एम्पिरिकल फॉर्मूला और मॉलिक्यूलर फॉर्मूला सेम है। सो अमाइड ग्रुप में चला गया एक कार्बन, एक नाइट्रोजन, 2 हाइड्रोजन और एक ऑक्सीजन। तो यहाँ पे कितने कार्बन और हाइड्रोजन बच गए? यहाँ पे बच गया 2 कार्बन और 5 हाइड्रोजन रिमेनिंग है। सो अमाइड ग्रुप के साथ जो अल्काइल ग्रुप बॉन्डेड है वो है C2H5 ग्रुप। तो ए का स्ट्रक्चर हो जाएगा C2H5CONH2 एंड ऑन बॉइलिंग विद NaOH ये फॉर्म करेगा C2H5CONA प्लस अमोनिया। अब जब हम इस सोडियम सॉल्ट का एसिडिफिकेशन कराएंगे it will give the corresponding acid that is C2H5COOH which will form a silver salt having the formula C2H5COO Ag. We had assumed कि empirical formula and molecular formula are the same. So हम percentage of silver निकाल लेंगे in this compound C2H5COOAg. तो उसके लिए weight of silver that is 108 divided by सिर्फ एक ही silver atom है इसमें. So atomic weight of silver that is 108 divided by molecular weight of the compound that is 181 into 100 gives the percentage of silver which is equal to 59.67%, which is same as given in the question. So the empirical formula and the molecular formula of the compound are same, and A is C2H5CONH2, B is C2H5COOH, and this is the silver salt of B. Question 43. A certain compound was known to have a formula which would be represented as, ये है given formula. Analysis showed that the compound contained 30.15% carbon and 5.06% hydrogen. When converted to the corresponding thiocyanate का formula ये है. The analysis was 40.412% carbon and 5.94% hydrogen. Find X, Y and Z. अब एज्यूम कर लेते हैं कि जिस कंपाउंड में ClO4 होल ट्वाइस है उसको मान लेते हैं 1 और जिस कंपाउंड में HCN होल ट्वाइस है उसको मान लेते हैं 2. कंपाउंड 1 और कंपाउंड 2 का जो फर्स्ट पार्ट है PdCx HyNZ ये दोनों में सेम है और ये जो सेकंड पार्ट है दैट इज ClO4 होल ट्वाइस और इस वाले कंपाउंड 2 में HCN होल ट्वाइस. सो कंपाउंड 1 और 2 में जो सेकंड पार्ट है दैट इज कंपाउंड 1 में ClO4 होल ट्वाइस है, कंपाउंड 2 में HCN होल ट्वाइस है, यही डिफरेंस है. बाकी जो फर्स्ट पार्ट है वो दोनों ही कंपाउंड में सेम है. और मॉलिक्यूलर वेट ऑफ 1 को एज्यूम कर लेते हैं m. द परसेंटेज ऑफ कार्बन इन कंपाउंड 1 विल बी इक्वल टू weight of carbon divided by molecular weight of the compound into 100. अब weight of carbon कितना होगा? weight of carbon होगा atomic weight of carbon जो कि given है 12 into number of atoms of carbon in the compound which is x. तो 12 into x divided by m into 100 is equal to 30.15. इसको सॉल्व करेंगे तो x की वैल्यू आ जाएगी 30.15 into m divided by 1200. Similarly percentage of hydrogen होगा weight of hydrogen in the compound divided by molecular weight of the compound into 100 and this is equal to 5.06. weight of hydrogen होगा atomic weight of hydrogen into number of atoms of hydrogen. atomic weight of hydrogen होता है 1 और number of atoms of hydrogen है y. so 1 into y is y and y by m into 100 is equal to percentage of hydrogen which is equal to 5.06%. इससे y की वैल्यू आ जाएगी 5.06 m divided by 100. Let this be equation 1. अब कंपाउंड 1 जिसका कि मॉलिक्यूलर वेट हमने अज्यूम किया है m, इसमें से अगर हम weight of ClO4 whole twice को subtract कर दें that is m minus weight of ClO4 whole twice which is equal to 199 और weight of HCN whole twice को add कर दें that is plus 116. 116 is the weight of HCN whole twice. तो हमें molecular weight of compound 2 मिल जाएगा which is equal to m minus 83. अब इस compound में percentage of hydrogen होगा weight of hydrogen divided by molecular weight of the compound 2 that is m minus 83 into 100 and this is equal to 5.94. इससे हमें y की वैल्यू मिल जाएगी. y will be equal to 5.94 into m minus 83 divided by 100. Let this be equation 2. Equation 1 और equation 2 दोनों से y की वैल्यू मिल रही है. इन दोनों इक्वेशंस को हम इक्वेट कर देंगे और सॉल्व करेंगे तो हमें मिल जाएगा वैल्यू ऑफ m which is equal to 560. Now putting the value of m in equation 1 or in equation 2 and solving, we get the value of y equal to 28. Putting the value of m in this equation, that is x equals to 30.15 m divided by 1200. Putting the value of m equals to 560 here, we get the value of x equals to 14. Now for value of z, we will add the atomic weights of all the atoms present in this compound 1. Atomic weight of palladium is 106 plus weight of carbon, which is equal to 12 into 14. 12 is the atomic weight of carbon and 14 is the value of x, plus weight of hydrogen, that is 1 into 28. 1 is the atomic weight of hydrogen and 28 is the value of y, plus 14 into z. 14 is the atomic weight of nitrogen into z. Z is the number of nitrogen atoms, plus 199. 199 is the weight of ClO4 whole twice, and this is equal to 560. Solving this, the value of z is equals to 4.